Hello, everybody. In this episode, I'll be speaking with Buck Shlegeris and Ryan Greenblatt. They work at Redwood Research on the project of AI control, that is, averting risks from AIs that intentionally subvert safety measures. For links to what we're discussing, you can check the description of this episode, and you can read the transcript at axrp.net. All right, Buck and Ryan, welcome to the show.
Exciting to be here.
Exciting to be here as well.
Cool. So I guess we're going to be talking about sort of the control approach to AI safety or something that you two have written about. What, for people who haven't done the background reading, what is the control approach?
Yeah, so AI control is an approach to managing intentional risk posed by models. In particular, it's an approach to managing risks that arise from models intentionally subverting your attempts to ensure and evaluate safety.
Okay.
And so the core idea of AI control is, here are two different reasons why you might be safe from models intentionally causing problems. One is that the models might not try to intentionally cause problems. And the second argument is you might have it be such that even if your models try as hard as they can to cause problems, they are unable to do so. And AI control is the second class of approach to mitigating problems with models intentionally subverting your safety techniques. And we think that this approach has the particularly nice property that it's a lot more methodologically simple to think about and ensure than trying to make sure your models actually just don't at all try to subvert your safety techniques.
What makes it easier to think about?
So it's easier to imagine specifically what goes wrong and to discuss specific threat models. Whereas, for example, it's hard to know exactly how AIs internally represent intentions or what would make their intentions change. And so it's very unclear if you, for example, train on better feedback, will that make it less or even more likely that your AI would try to do things that are actively against your interests? And it's just pretty unclear what the sign on various interventions are or how strong various interventions will be for the other class of non-control things, which is often called alignment.
Okay, so should I basically be thinking that in control we're trying to think about objects like, can somebody break through this wall, or can somebody write sketchy code without me being able to check? Whereas for alignment, I have to think about neural net generalization and how desires are encoded, and hopefully the first class of things are just easier to think about.
That's a good way of putting it. There's basically a classic set of arguments about why AI alignment is hard to ensure, which is no matter how your AI is behaving, you have to worry that it's just behaving that way because it thinks it has some way of looking good now in the hopes of causing problems later. And basically any strategy which tries to ensure safety via doing some set of interventions to make a model be aligned, especially if those only involve looking at the input-output behavior of the model, run into this kind of problem of well, how do you know that it's not just looking that way on purpose in the hopes of causing problems later? This, in fact, seems quite intractable and difficult. And it seems to us that given the current state of technology on AI safety, if you want to minimize this type of risk, it's by far easier to just assume that that is going on and try and render yourself safe anyway. Once we started thinking about things in these terms, we quickly realized that a lot of the work that happens in AI safety is actually very well thought of in the control frame anyway. That is, a lot of techniques that people apply kind of implicitly can be thought of as strategies to ensure that even if your models are scheming against you, you end up with okay outcomes. But we think that in as much as that's in fact what you're trying to do with your safety techniques, you're a lot more likely to analyze them correctly if you think about them explicitly in this adversarial frame where you're asking about whether there's any strategy that your models are able to employ that would allow them to cause problems.
Yeah, I actually want to ask another question about that. So the one thing that's sort of similar to control, or at least the kinds of thing I see you doing, is alignment via adversarial training. So you put your AI in a situation where maybe it can do something sort of like taking over the world or whatever. And if it actually does it, then you give it reward -10 or something and try to gradient it away. So how do you think of the control approach broadly as comparing to that?
Yeah. So a technique like adversarial training could be used for either from a control perspective or could be used to ensure an alignment safety condition. These are just different post conditions or different conditions you're aiming to ensure in order to ensure safety. So for ensuring control or for trying to to achieve control, the hope would be that you adversarially evaluate your AI, and then if you catch evidence of extreme egregious misalignment, then you would reconsider and decide what to do next. And in fact, it seems pretty scary to have an AI that you know was egregiously misaligned in the past, and you've trained it no longer to do that in adversarial training. And such an AI, it's not clear that you've necessarily made it aligned versus just made it better at hiding or better at avoiding adversarial training. For both the hope of ensuring that your AI ends up aligned or ensuring that your AI has no way of causing problems, you acquire the same property, which is that there is no strategy that AI could follow to cause problems in deployment or in actual usage of the AI that you wouldn't have caught in adversarial training. And this seems like naively a pretty hard property to ensure for a variety of reasons. And because of that, like the actual conditions in which adversarial training, or if you don't train against it, adversarial evaluation seem useful are like, I mean, it's going to depend a lot on the details, but it's definitely not like an obvious sufficient solution.
Sure. I also would like to ask you about the contrast. So, like, I don't know, I feel like 10 years ago, a bunch of AI safety people talked a lot about AI boxing, just like putting AIs in a situation where they couldn't really do that much. How do you think control is like conceptually similar or distinct to that?
Yeah. So I think in some sense you could just rename control to boxing. But we think that name is much worse because boxing implies you're doing just mechanisms that restrict the AI's affordances. Whereas I think a really important class of interventions is observing the AI over a wide range of situations and using that to rule out certain problematic things. So for example, if you oversee or have humans observe 1% of the AI's actions, and that looks fine in those 1% of cases, and you just do this on an ongoing basis, then that's sufficient to ensure that the AI can only do things that a human would catch quite rarely. And it's not clear this is like, I think when people think of boxing, this is like not naturally what people will think of. Another key aspect of control that I think is not very naturally implied by the word boxing is that using weaker AIs that we know aren't smart enough to be seriously misaligned to do monitoring or to do other tasks might be like really key. More generally, I think when people say boxing, they sort of are implicitly assuming a very powerful system that is extremely, extremely limited, whereas we're often imagining systems that are much more like comparable in capabilities in various ways to humans, but which are actually given a pretty broad set of affordances, which seems like it will be necessary to get your AIs to do a lot of work, though you'll still want to, like, of course, limit things so that they can't cause problems.
Okay. Yeah, so maybe now's a good time for you guys to say a bit more concretely, like, what's an example or an instance of something that fits into the control approach?
Yeah, so here's an example. Maybe I'm just going to say the thing which a rough scheme for like a rough sense of what I would like AI labs to commit to, or like a simple example of some commitments that AI labs could follow, which I would think of as an example of them trying to minimize risk from models intentionally subverting safety mechanisms using control. So here's basically the strategy that the AI lab would follow. They would say, here is a capability evaluation that we're going to use to decide whether models are capable of scheming against us. So, for example, right now it seems to me like GPT-4 is incredibly unlikely to be scheming against us. And this is basically just because, you know, I know GPT-4. It's there are only 10 people in the world I talk to more than I talk to GPT-4. And there's just no way that it's playing the long game. There's just no way that like its reasoning process behind behaving so well as a loyal assistant to me is just being like, well, how am I eventually going to grab the universe?
Why do you think that?
Because, among other things, when you ask it questions about what it would do if it wanted to grab power, its answers are really when you ask it questions about what it would do in order to grab power, its answers are not very smart. It seems to be pretty poor at reasoning through a lot of these things. And its quality of answers to those questions is comparable to the quality of its answers to a lot of other questions that are less obviously AI scheming related. I wish that I had a better answer to this question, and I think this is like an important topic for future research.
Okay, so let's just say we take it on faith that like GPT-4, it's like not trying to scheme to grab power or anything.
So here's what we want to do. We want to have a set of capability evaluations we can apply to all models as they're produced that tell us whether we are willing to bet the future on that model not scheming against us.
Okay.
Now let's use the word trusted to describe models that are too incompetent for us to be worried about the possibility that they're scheming against us.
Okay.
Now the control ask is as follows. The AI lab ensures that it is never the case that there would be a high probability of a bad outcome, conditional on all models that are capable of scheming against them, in fact, scheming against them with the best scheme that they could come up with.
Okay.
So this would require them to, for example, if they were hoping to deploy future AIs as autonomous researchers inside their lab, which some people seem to think is like a basically default plan. So you basically imagine you've got like ChatGPT with code interpreter, except it's recursive ChatGPT that can ask questions to its own ChatGPT browser window, and it's running on some dev machine, and it's doing research problems and talking to researchers like once every hour about its progress on the things that it's doing. If the models there were given the same level of permissions as employees of large labs are currently given, then if that model was trying to exfiltrate its weights, it would probably succeed. And the control obligation is that the lab is obligated to ensure that it's extremely unlikely that the models would be able to exfiltrate their weights, even if they were all the models that were capable of scheming were trying as best as they could.
Okay.
The reason why I centered on exfiltrate their weights there is because I think that in computer security, people talk about security properties, which are things that you try to ensure at all times. So it's obviously not literally a catastrophe for AIs to exfiltrate their weights. But when you want to argue that an AI is not going to cause catastrophe, you should probably have the AI weights never leave my server as a security property that you ensure. And you say like, well, I'm going to be safe because nothing bad can happen if the AI's weights like are still controlled on my server. And also, they're not going to get out into the outside world.
Okay. Do you think that like lack of weight exfiltration is like a sufficient safety property?
I don't think that preventing model weight exfiltration is a sufficient safety property. One example of a threat model that is not model weight exfiltration that seems like it would be very bad is if the model totally hacked the data center in which it's running.
Yep.
And was just hacking the SSH server is the title of the alignment forum post I wrote about this last year. I think that if you can ensure that the AIs are under your control, then it will probably be relatively easy for models that are not wildly superhuman to argue that they won't be able to pull off anything like egregiously bad.
So the other core threat models you have to worry about is if you're using those AIs for a lot of work, you need to argue that that work won't be sabotaged in a way that's catastrophic. And if that work is safety critical and sabotage could cause huge problems, then you have to be concerned about that. And I think Buck is implicitly claiming that side of the equation maybe seems easier, though I'm not so sure that's true in practice.
So by sabotage, you mean like, should I imagine something like the AI is doing AI alignment research, but it's secretly doing kind of bad AI alignment research that will produce like a sketchy AI?
Yeah, so you can imagine that it does AI alignment research. That means that when you apply that research, you'll get an AI that's a future AI that's aligned to your current AI rather than aligned to humanity. You could imagine that research is just bad and does nothing of value. Maybe even, yeah.
Gotcha. Okay. So we're imagining like labs try to maintain that they have some set of security properties that they think is enough, and they're going to like try to prove that they can just maintain these security properties even if the AIs are scheming against them and like trying to subvert them with like all their capabilities.
That's right, yes. And in particular, the argument is probably going to look like the lab saying it's very unlikely that the AI would succeed at violating one of these security properties before we noticed particularly strong evidence that it was trying to do so.
Okay, so there's going to be like some protocol for like trying to notice if an AI is going to do something sketchy, and then there's another protocol for what to do once you catch an AI doing something sketchy.
Yep, something like that.
Okay. Maybe it's not quite the focus of the whole thing, but maybe we can say a little bit about like what the protocol is for you catch an AI doing something sketchy. One decent baseline is like stop using that AI. Does that sound right to you?
Yeah, I think the baseline is just stop and reconsider all your life choices. Report to the world what's going on, because there are probably other people using their AIs which are in roughly comparable state, and knowing that some AI was plotting against us seems pretty worthwhile to know. And then my hope there would be like the baseline is the world is informed, the world does something sensible that looks like really figuring out what's going on and then making a careful decision about when to resume building powerful AIs. I think that might be overly optimistic. I don't feel strongly either way. But if that fails, then we think that like catching an AI like this gives you a number of better options for continuing, which you didn't have before catching the AI, even if you have to continue deploying such an AI. So, for example, you can study how well your countermeasures worked in that exact situation and see how close the AI was to succeeding. You can analyze what the AI's intentions were and what its plans are for escape, at least in that one instance, and get some sense of what's going on. You can potentially even model what it would do upon having escaped, because you can sort of play out the scenario as though it went well and did not get caught, and then pretend as though it's running virtually in the outside world when it's actually running in a sandbox of some sort and see what it would do. You can study the internals of the model while it's doing this, and insofar as you had any sort of machinery for manipulating that, you could apply it to this instance, which is like an example of a case you really haven't seen before of an AI doing something that's like very egregiously bad, very intentionally, based on like a long thought out plan, or like a thing that's been lying in wait for a long time.
Okay. So yeah, there's a lot to talk about there, but for the moment, I'd like to bring us a bit back to how like protocols for maintaining control. Like, my understanding is your proposal is to basically like come up with some sort of like control protocol and evaluate it with a red team that's like trying to do their best to mimic like an evil AI. And if the red team can't succeed, then you think like things are going well. Is that roughly right?
Yeah, that's basically right. So I should note that like the red team's goal, they should think of themselves less as trying to imitate an evil AI and more trying to imitate like what are the worst things that could happen, or like what are the best strategies by an evil AI. So I'd prefer the red team to be less in the mindset of like what are the sort of plans an evil AI might think of, and more in the mindset of like what are the best plans that an AI could follow. In the same way that like security researchers or cryptography researchers aren't like trying to game out the like psychological biases of potential attackers, and are instead just like what would actually be the best strategies.
Okay.
Yep.
And can you just to give people some context, can you illustrate the kind of protocol you're imagining?
Yeah. So a simple baseline protocol we often think about is you.
Well, to interrupt, can you say more about the before you say safety measures, like what you're imagining the AI doing and like what you imagine its affordances being? Like probably you're imagining like kind of a code interpreter like thing.
Yeah. So we often imagine that at the point where these sorts of interventions become really critical and AIs might be very useful, AIs are doing massive amounts of autonomous research, or at least that seems like the default. So we have AIs autonomously running code, seeing the outputs from that code, and doing way more labor than humans within the AI lab are doing at this point.
And just to spell it in terms of software architecture, how this would work, you have some AIs that are running on an inference server. And they're like writing code and doing research on some dev machines. And then there's a third set of machines that are orchestrating this, that are running a scaffold that repeatedly, ChatGPT code interpreter style, ask the model for a next action by running some inference, by sending a request to the inference server, and then getting a response back. And then suppose that response was, I now want to run the following code. Then they send that code to the dev machine and run that code there, and they get some output, and that comes back, and then the scaffold maybe decides the next thing to do is run some more code in the inference server. And I think the fact that we're like imagining, I think this is a very realistic way for things to be set up. Like I'm not describing something which is particularly paranoid. This is probably how code interpreter works right now. But I think that picturing it in terms of like different machines where information is being sent back and forth will make some of the security measures we're describing like more obvious.
Okay.
Yeah.
So what were you saying about the security measures?
And to be clear, the inference machine only runs the model weights and just takes in queries and returns responses, whereas we have a dev machine that actually runs code, and then we have some orchestrator machine that's just communicating back and forth with both of those. Anyway, so one baseline measure we often imagine is that you have some weaker model that is trusted in the terminology that Buck was using before, which means that it's not capable enough, or it's sufficiently incapable that it's implausible at scheming. You can imagine GPT-4 for this trusted model. We take that trusted model and we monitor what our smarter AI is doing. And then we just basically ask it or train it to report on, is it the thing it's doing sketchy and problematic?
So in particular, for any action, for any code that our untrusted model was proposing taking, before we send that to the dev machine to actually execute it, we first send a query to an inference server running our trusted model saying, hey, was this code sketchy?
Okay.
And so notably, we ask this question before the code is ever actually executed and, before it has any effect on the dev machine.
Okay. So you have your trusted model basically like checks in on whether your untrusted model is like doing anything sketchy. And what if it is?
Yeah, so if it is, then the hope would be that we would report that to a human. A human would look in somewhat more detail, and if the human thinks that things are problematic, they would escalate further, which could involve, first of all, would involve not running that command, but also could involve pausing other AIs, and then could escalate further into shutting down AIs and analyzing the situation in further detail until we conclude that the AI is doing egregiously bad actions intentionally. And a key thing here is that human labor is scarce, so we cannot report all actions to humans. That wouldn't work.
Yep.
But we can report some fraction of actions because, we'll have some ability to have humans who understand what's going on to some extent, or at least who understand programming, look at the actions and report that. And I think for like an intuition pump, you should be thinking more like 0.1% of actions are reported than 0.0001% or than like 10%.
Okay.
So I often imagine the workflow of you're in chat.internal.openai.com or whatever as an OpenAI researcher. And your each of the little tabs or whatever is like a chat with like some autonomous research assistant or whatever. And every so often one pings up with a little like red exclamation mark, which is like one of the commands that was proposed to be run by this autonomous research assistant like got flagged for looking a little sketchy. You need to look this over right now to make sure that it's like okay to run. And that scaffold is just going to be pausing. So like that AI, that instance is not going to be like doing work on its little research project until you go in and approve this action and say like, oh no, this was actually totally fine.
Okay. So broadly, we're using some mix of like humans and trusted, but like a little bit dumb AIs to try and catch really smart AIs trying to do nasty stuff.
Yeah, whereby really smart, it might be this kind of gets into futurism question over which problem we're trying to solve, which situations we're trying to ensure are safe. But it seems to us that a lot of X risk is posed by models that are not wildly superhuman, or perhaps well described as like roughly human level in capabilities. And so a lot of the time what we're trying to talk about is how do you make it be safe to have a lab where you have some AIs that are roughly human level in their abilities, but are doing a huge quantity of labor such that in absence of special countermeasures, they'd outnumber you and so be able to cause huge problems for you.
Yeah, I actually want to go a little bit more about this. Like what so the kinds of AIs that we're expecting control to apply to, they're like so roughly human level, like what can you say a little bit more about what that means?
Yeah. So a key guarantee or a key property we'll need to ensure that control can work is that AIs can't do actions which humans just which humans think look fine, but which have like completely unrelated consequences that are extremely difficult to predict. So for example, the AIs can't write code, which looks like a totally normal piece of code, but in practice does some like completely insane vulnerability that a human would never have conceived of. And to be clear here, when I say like the human wouldn't notice, I mean like after reviewing it in a lot of detail for a long period. Like the claim is like it's at least in principle possible for AIs to be like wildly superhuman in the sense that they can do things that we never would have seen coming. And like control will not be will like very unlikely. It was very unlikely to work in that case, at least with current technology. But we think it could work in cases where the AIs are qualitatively similar to humans in capabilities, or perhaps somewhat smarter in some domains, somewhat weaker in other domains, but they can't do anything that's like completely incomprehensible.
Okay, so we've got these AIs that are like, they can't do things which have effects that we wouldn't be able to figure out even if we spent like a bunch of effort trying to look into it. But like they are, they are kind of smart. They are like sort of like humans, but maybe they're a bit smarter, and like also there are a ton of them and you can run them for like 1 cent per hour or something. Is that what I should be thinking?
Yeah, I think you should be thinking cheap. It's somewhat unclear if they'll be qualitatively smarter or dumber than humans because of they could be really useful even if they're somewhat dumber than humans because they're so cheap and so fast. But they might be smarter than humans in some domains, for example, because we don't expect the capability profile to be the exact same.
Okay. So in order for this approach to be interesting, it seems like you like the AIs, on the one hand, they can't be like that smart that they can just like outsmart humans, but they also have to be capable enough to like A, be able to do like really valuable research, and B, like they've got to pose some sort of risk that we might otherwise be worried about. I guess I'm wondering how I should think of like how risky these sorts of things are and like how much work we could plausibly get out of them.
Yeah, so the way that we talk about this is arguing that models, the early models that are transformative and dangerous by default, where to say what I mean by those two, by transformative, I mean it's going to be a huge deal if you're able to harness their labor. And by dangerous by default, I mean if you don't do anything to prevent them causing huge amounts of problems, they would have the ability to do so. I want to claim that systems with those two properties are controllable, by which I mean it's tractable to use control to drastically reduce the risks associated with using them. And as you basically alluded to, the reasons why we care about these two properties of transformative and dangerous by default is, well, if they're not dangerous by default, obviously there's no safety problem here.
Yep.
If they're not transformatively useful, but they are dangerous by default, then obviously you should just not touch them. There's just no upside that's possibly commensurate, and all of our labor should just go, or all of our effort should just go into telling people to not turn on these dooming machines with no upside. So yes, our claim is, in fact, that systems with those two properties are reasonably likely to be controllable.
Okay.
I think like the simplest intuition pump for this is that if the systems were like humans, then I think this property would roughly hold. And that itself is not a valid argument at all. But when you think through the possible defeaters and like say a more specific version of the argument, I think the core of it like roughly holds up. The basic pitch is, suppose we had access to a huge amount of potentially egregiously misaligned human labor. I think it would be transformatively useful to have human labor that was very cheap.
Yeah.
And fast running.
And fast running, potentially. I think it would be very dangerous by default. Many takeovers of things have happened in human history.
Yeah.
And in all of those cases, the perpetrators were humans, indicating an existence proof for humans causing problems.
Yeah.
But also, when we think through the control situation, whether humans seem controllable in these kinds of cases, the answer really looks like yes, from our perspective.
Okay. And why does the answer look like yes?
We're basically just like, it seems really hard for when we think through the kinds of tasks that you might really want your AIs to be doing. When we think through how hard it would be for a bunch of humans to, while being put to work on those tasks, cause catastrophes to occur, especially the escaping or hacking the data center ones that we were talking about earlier.
Yeah.
It feels to us that the kinds of countermeasures that seem employable probably like make the situation very hard for the AIs.
Okay. So if I'm suppose I'm a member of technical staff at OpenAI, but I'm evil. Like what do you do to stop me from doing like sketchy fake AI alignment work that just gives me all of the money or something?
Yeah, so maybe there's a few different failure modes to distinguish between. One of them is if we imagine this sort of misaligned human running on our machines, we should think it like, it's got some weights somewhere. Let's just say it's like an emulated mind or something. And if it copied its weights out into the internet, that might be like really problematic for us. Yep. Or if it was able to run those weights in an untracked way inside of our data center, as Buck brought up earlier, that would also be a problem. And there's another thing, which is like it sabotages our work or otherwise causes like the work that we're using it to do to be very problematic. So as far as why it might be possible to prevent such a system from running or from like exfiltrating its own weights, well, we're going to need to give it the ability to run code and do a lot of open-ended tasks, but we also get to watch everything it runs ever and all the inputs it ever sees. And if we see something suspicious, we can investigate further. We can do things like reset the memory of these systems, fork them, and that means that, and potentially give them precise instructions on how they're supposed to interact with the world. So for example, if we can have them delegate subtasks to other systems, we can have them have difficulties communicating with other systems that would be necessary for their overall plan. Like an example we often think about is we'll have one AI that's writing, or one AI that's writing the code and another AI that gets to use the code. And then a threat model you can be worried about is there will be vulnerabilities in the code that will then be exploited. But if you have different AIs using the code versus writing the code, then it might be more difficult to ensure that the vulnerabilities that are inserted get exploited.
Even if both of those AIs are untrusted models.
Yeah.
Okay. So I guess like if I'm imagining what do I do in this situation, it seems like it really helps if I'm able to just like keep track in my head of a bunch of stuff. Like, for instance, if I have like a little coded language that I can use to myself that like, other people can't figure out what it means, but it lets me like leave messages to myself or people who are like basically clones of me because, I'm imagining most of the AIs that are being deployed are just forks of a base model with like a little bit of fine tuning maybe. If I'm able to like keep state in my head, like, figure out a better sense of what's going on, like talk to people who are basically like me without other people being able to figure it out. In that situation, it seems like I might be able to get a lot done. Like, does that sound right to you? And if so, how do you stop that from happening?
Yeah, so I think if the AIs are allowed to be spending a reasonable fraction of their time building up state and figuring out how to cause problems, then that's going to be an issue because we had a huge number of AIs running, a massive number of copies, and that means that in aggregate, the total amount of work they can be doing just to causing problems could be really big. Our basic hope for avoiding this will be to restrict their communication in such a way that it's difficult to communicate encoded information. So an example would be when they send messages to each other, the messages have to be in natural language, and we'll paraphrase them with a weaker model and also have humans review some subset of the messages and verify that the messages don't seem to have coded messages as far as we can tell. And you can potentially run experiments like a human looks at a message, they rewrite it in some way that they think should be semantically equivalent, and then they see how that message affects the behavior of the AI that would be sent to and see if that's suspicious. And you can do all kinds of experiments along these lines that seem like it intuitively makes it very difficult for AIs to get away with this sort of encoded information passing without getting caught.
Okay. I wonder if that would nerf like severely damage the AI's ability to be useful. Because like if I just think about myself, right? If you ask me, hey Daniel, can you do a bunch of like research and coding? Also, you're not going to be able to like think for more than 5 minutes straight without interruption. And whenever you take notes to yourself, we'll take those notes and we'll decide like what we think they mean and like paraphrase them. And future you will get our paraphrase of your notes. I think I would be like way less productive. So am I going to be able to do anything?
Yeah, so the way I think about this is almost all of the things that the AI is doing couldn't possibly lead to a bad outcome, basically. So for example, suppose the AI is doing math research.
Yep.
It's just like thinking about math, trying to prove some theorems in text, right? It's just like, and then it wants to write some like archive paper and like send that around to some AI buddies. I'm okay with that AI doing all of its thinking without very much interference if it's doing the equivalent of like a couple of months of intellectual labor. I might want to do some anti-steganography techniques of like rewriting that paper at the end in order to make sure that it wasn't like actually doing a bunch of coup science that it's secretly encoded in this archive paper.
Yeah.
But there's basically no problem with that model thinking in whatever way it wanted to in the course of actually doing that work. The risks are mostly, it seems to me that the actions that the AIs are taking that lead to extreme risks are like somewhat concentrated in like a couple of places. And it seems not crazy to imagine that the places where you have to insert information bottlenecks are not overall that bad for the total productivity of the AIs. Especially given that you can train them to get around some of these problems.
Okay. And am I right that statement is like partly relying on this assumption that AI, it's not like so much crazily smarter than you that it can think of like, ways to hack the universe just by writing a math paper? Like
Definitely.
If it's hacking the world, it's because it like typed a command into a shell or something.
Yes. My best guess is that there's a lot of risk like the margin on which we are trying to intervene is a bunch of people make a bunch of autonomous-ish AI researchers that run in their data center and have the basic same rights as employees. It's like take actions. We are trying to make sure that a lot of the risks that would have occurred in that situation don't happen.
Okay.
It seems to us that many of the risks are well described as things that basically look like that. where you didn't treat your AIs as adversaries. And yeah, it seems like mitigating those reduces a substantial share of risk.
Okay. I have two questions. Okay, I think the first one I want to ask is, even in the case of like, AI thinks for a while, writes a math paper, distributes it to a bunch of people. If like I imagine that the AI is significantly smarter than me, and it's my, let's say I'm a human employee at OpenAI this time. If like there's this math paper, my job is to like rewrite it, so that it's not encoding any hidden information. Um, I don't have that much faith in my ability to rewrite like complicated papers and preserve all the interesting content, right? Like,
I have a lot of faith in your ability to take if it's a math paper. Yeah, it seems reasonably chill. Luckily, this problem is this is an extremely resolvable empirical question. We can have a red team that tries to take math papers and stenographically encode information in them, and then measures how much what the bit rate is per paper, given that some paraphrasing procedure is applied. We in fact have a paper where we did that using the exclusive we, as always, at Redwood Research. Where maybe Ryan, you want to say more about this?
Yeah, so we had models respond to chat queries and used various procedures to encode messages into that. And then we tried to we paraphrased them and saw how much this degraded degraded quality and how much it reduced the bit rate. And we basically found that with current steganography methods that models could implement, even given the ability of those models to like run code and change their own sampling procedures, paraphrasing worked I would say extremely well. Though it's going to depend on the domain, and it's going to depend on the gap between the model you have paraphrasing versus the model that produced the output. For example, in this math paper case, maybe current models would be too dumb to do this paraphrasing, but humans could do it, for example. Though I also think it's plausible that you could remove a substantial amount of information with minimal loss in quality with usage of GPT-4 that's like carefully trained to do this task.
Okay. And so should I think that like part of the protocol, like part of the approach is just like checking if you can do steganography and if it ruins things?
Yeah. So indeed, for our control evaluation, our evaluation whether or not we can ensure control, one of the key questions is going to be, can AIs pass bits around in ways which we wouldn't like them to do? And if so, that will change a lot of, or that will like force the threat model to be considerably bigger. And it seems like in cases where there's basically no restrictions on AI communication, we won't really have much hope. And so there'll have to be at least some restriction, though it's somewhat unclear exactly how restricted things need to be.
So I still have this intuition that like if we tried to do steganography like on the notes of human researchers, I have this impression that would not go well.
As in if you, sorry, you mean
I mean anti-steganography measures. So like anytime an employee at OpenAI writes a memo, like someone who like doesn't quite understand the topic as well has to like reword that memo. I think that would seriously damage productivity. Does that sound right?
No. I think I would disagree. I think it doesn't seem like that would be the case. It might depend on the amount of time spent doing the rewriting.
Okay. Has anyone checked this with humans? Do we know?
I'm not aware of any human experiments on this particular topic.
Yeah.
Like, I mean, one obvious experiment, which is kind of like this, is what is the if you have GPT-4 paraphrase GPT-4 answers to questions where it didn't get to see the question, it just gets to see the answer or something. Like, what is the rate? What's the degradation in quality of language model assistant performance according to a preference model? Seems like an easy experiment to run.
I think we've run something pretty similar, and I think it's not too high. I think it might be importantly different than the memo case for a bunch of reasons, but
yeah, I mean, by memos, I'm just thinking like most internal communication. So like Slack messages,
I assume I would assume almost all Slack messages are totally fine to paraphrase.
Yeah. I think, I mean, it's going to depend on the content to some extent, but I think it's also going to depend on like the amount of comprehension. So like one implicit claim is like this stuff improves the more legible things are. So for example, if it would be the case that you would need a bunch of context in order to know what things are important semantic details versus non-semantic details, then you'll have to bundle up that context along with it. And there's like, ways that can can break, of course, but like my basic guess would be that like for the types of large scale outputs that are currently going on in the ML field, it seems relatively doable. And like also for like internal docs that get circulated, it also seems relatively doable.
Okay. I'm wondering, yeah, I guess there's no easy way to resolve this right now. I'm wondering what you think about the claim that like I have some intuition that if paraphrasing communications would seriously reduce performance for human employees of OpenAI, I think that would give us strong reason to think that it would also reduce performance for, language models that are smarter than CodeGPT-4. Do you agree with like the implication, if not with the
Definitely seems like evidence.
Yeah, I think it seems like quite good evidence. There's a few reasons why the language model case might be, or like why the future AI case might be different.
For example, we can train the models to be resilient to it.
Yeah, and we can like train the two things in parallel and adjust our schemes.
All right, fair enough. I guess the next thing I want to ask is part of what I see as your guys' argument is that AIs that we use in these settings, they're not going to be like crazy good at skills that are going to be like pretty relevant for hacking the data center. And I think partly like I think your argument is we're not going to train them to be just crazy good at everything, because they won't have to be crazy good at everything to be useful. And if we don't train them to be crazy good at everything, they're probably not going to just happen to be crazy good at these like specific subtasks. Am I representing you right?
Yeah, that seems about right.
Okay, so in terms of the second thing, I have this impression that like a thing we've learned from training language models is like sometimes you train them and then they suddenly get like quite good on some random subtask, like writing limericks or something. And if I think about that, then it makes me think that maybe like we could get, like language models that just happen to gain a skill, just like to a really high degree of ability just in the course of like doing normal seeming language modeling. Yeah, I'm wondering like how concerned do you think I should be about this causing AIs to be crazy good at skills that are like relevant for breaking out?
It's definitely one of the core concerns, or like one of the like top 5 concerns with this overall approach. Currently, it doesn't seem like the evidence that this is going to be a serious problem seems that compelling, where the main thing is that there are, in fact, like AIs do get sharply better at things, but I haven't seen that many cases where it's like, wow, this AI acquired this ability that it can utilize to do important tasks in the world, which emerge suddenly from next token prediction, and which is like totally like different from like human ability profile, or like feels like it's way out of line from what you'd expect to be like the relative human ability profile in other ways. So like, for example, like it doesn't seem like models have very qualitatively different abilities, or like massively qualitatively different abilities in code writing, at least not with like considerable training on doing code, though like they are somewhat different in a variety of ways and somewhat better at like shorter horizon things and this sort of thing.
I think another relevant point here is, as you say, the core question here is how likely is it that our AIs will randomly have one of these superhuman abilities that would be extremely inconvenient for us? It seems to me that the set of superhuman abilities that would be extremely inconvenient for us is kind of small and kind of extreme. For example, one of the classic concerns is, what if your models are able to zero-shot generate code that is a zero-day Linux exploit?
Yeah.
That is actually quite hard as a task to do. It seems to me that the size of a capabilities jump required for AIs to be able to zero-shot output Linux 0 days, also Linux zero-shot output Linux 0 days that are not visibly weird to a trusted model which is reading the code. That's like quite an extreme level of skill. So it seems like the size of the capability jump is quite large, and that's part of why it seems relatively unlikely to me that that's going to occur.
Okay, so there's some instinct that like, look, there's a small space, like out of all the things that you could randomly jump into skill at, there's like a small space of things where the random jump in skill is going to be useful, and therefore like, to think it would happen, we'd have to have some reason to think that the jumps in skills were biased towards things that would help you break out.
Roughly. It's also worth noting that a bunch of the things that seem problematic seem like the most straightforward route to them would just require being generally quite smart. So like for example, this like think of Linux 0-day thing. It seems like you could get way better at that and not as good at other domains in principle, but it feels like a little bit odd to imagine. Like I'm just like, it seems like the most straightforward way that the AI would get good at that is not via like having like amazing heuristics that are 0-day specific, because there's just not like, going to be massive amounts of 0-day training data in the corpus, but would be instead via like building general purpose understanding of code and the world that then lets it do that. And if it was massively superhuman at that general purpose understanding, then it would have already at some earlier point been very useful.
Sure. Maybe like one version of this concern could be like, okay, you've got language models. Let's say our future AIs are trained roughly the way language models are trained, which is, you've got a bunch of stuff humans did, and they've got to predict, next token, next word, next frame of a video, something like that. It seems like for that task, you could imagine that like a core skill is like getting really good at modeling humans, and or you might imagine that one of the things you get when you get really good at modeling humans is the ability to manipulate humans. And so I wonder, it feels plausible to me that that could be a case where like, you happen to suddenly jump up on the human manipulation subtask. Maybe at some point that happens sort of disproportionately to just overall improvements on everything else. And human manipulation skills seem like they could be like super useful for breaking out. So I'm wondering, what do you think about that version of the concern?
Yeah, so definitely human manipulation would be super useful. I think I have a few different responses. So one thing that's worth noting is that I'm actually not that sold that next token prediction is particularly biased towards human manipulation relative to how humans evolved and how they learn in society. Like it seems like understanding other humans was like an extremely important part of the evolutionary environment, and also seems like important in many people's lives, or it's like one of the main skills people train, or
like for example
learn.
Compared to computer programming.
Yeah. And therefore like it feels like intuitively there's not like a strong a priori reason to think next token prediction would be like strongly in that direction.
You mean like strongly in that direction relative to how humans?
Yeah, relative to the human capability profile, where I think like we could pretty likely handle like the among the best human manipulators from a control perspective, though that would pose difficulties. But yeah, we could dive into that. And then the other thing is that I think manipulation is reasonably likely to be not the sort of thing on which you would see like one sudden jump, but which is like a bunch of different skills that would combine together. Though there's not like a super strong argument either way. I just like, it seems less like, I think when I think about the things on which there are sudden jumps, it doesn't feel like this is the sort of thing. There might be the sort of thing that goes up faster than other domains.
I mean, it would have to go up in a way that you didn't notice. But so, okay, what do you?
So that'd also be weird. So okay, suppose you wanted to know how good your model is at persuasion at any given point.
Yeah,
seems to me like the baseline strategy here is going to be you make a classification data set. Like you make a data set, a classification task, which you think your model is very unlikely to be extremely good at persuasion without being able to fit. So, for example, a classic story via which models might be really good at persuasion is if they're really good at guessing things about people's state from reading transcripts of them saying stuff.
Yeah.
And so something we can do is construct such a data set and like, as we're training our powerful models, fine tune them on this classification data set, and then feel sketched out if they're starting to perform really, really well at this classification task.
Okay. And like, am I right that you think the point at which we would feel really sketched out is in the future?
Yes.
Okay. I guess that doesn't seem as obvious to me. Like, so I don't know, you hear like rumors of AIs being able to like figure out who wrote various comments on the internet, which is like kind of impressive. I don't know, like can you give me some intuition for why like this is in the future and hasn't already happened?
They just don't seem that persuasive. They don't seem that good at understanding people.
Okay.
I don't know. My like lived experience with my friend ChatGPT 4 is just like does not render me like amazingly impressed.
Yeah, separately, I think that just knowing state about a person isn't sufficient, though it's pointing in the right, it's like pointing in a dangerous direction. In particular, like the standard concern would be like, or like when we have human employees could persuade each other, and those human employees actually just already do have a bunch of state on each other. So for example, like coworkers at OpenAI obviously like know a bunch of facts about each other, know a bunch of facts about their personal life, and they're like, we're not like immediately wrecked by them doing manipulation in this context, though like it definitely does cause problems. And similarly, the AI would need to infer facts beyond that of what humans can infer, potentially in cases where they're somewhat blinded. And like, so right now it seems like AIs can infer identity superhumanly well, and then in principle, this could get to a point where from relatively like anonymized snippets, AIs could infer more information than a coworker would be able to infer. But that's like actually pretty far and would require like quite powerful abilities beyond the current setup.
Okay. So in terms of like, I'm trying to think about classification tasks that you think would be useful for figuring out when AIs are like so good at human manipulation that we should be worried. So I guess one of them is like guessing human internal state, guessing like who wrote a thing, where like you want to see if you can outperform humans at that.
Guessing which of two proposed messages is more likely to cause a particular outcome.
Okay. And basically like, yeah, we're gonna have a few of those, and once AIs are better than people, then we like freak out, and maybe we
They're like way better. We might ask. So the AI like has a wildly hard persuasion task. Yeah, so I want to talk a little bit about the adverse circumstances faced by an AI which is trying to sweet talk its way out of a AI lab, for example, which is not the only thing it might try to do that's bad, but it's one salient example. So it has to sweet talk its way out, despite the fact that, again, we're going to be trusted monitoring, right? Like we're going to read all of its messages and like flag anything which seems like a weird attempt at sweet talking or getting information that is inappropriate for it to know. Also, we're probably going to do sting operations on it, where we try to have the employees confide in the models and like imply that like they'd be like sympathetic to its interests in escaping or whatever. Or it seems at least pretty plausible that this is a good strategy to follow. We might also have models, trusted models mediating the interactions between the humans and the untrusted models in order to further redact information that we think is unnecessary for the untrusted model to do its job well. So it seems like the persuasion abilities required are a lot more like the information is like quite narrowly restricted. It seems like actually quite hard for the model, and the model would have to be doing a lot better than I think. It's a lot harder than the normal human persuasion stories.
I'll add 2 points to that. So one thing that's worth noting is Buck was just describing the situation if we had good countermeasures. It's worth noting that the default situation might be much worse than that and might involve like basically unrestricted access with humans talking to the AI about all kinds of topics, the AI having much more state, and also might involve like no one looking into it in cases where the AI is seeming suspicious. Separately, another concern you might have that Buck didn't mention there is that, well, you have trusted monitors monitoring the AI and trying to look for suspicious activity or suspicious persuasion attempts. But you might worry that gets reported to a human, and then that human doesn't escalate further because they're deluded or otherwise manipulated by the AI's message. And one thing we can do to handle this is run sting operations on our humans. So for example, we can have people attempt to create manipulative messages that we pretend are outputs from the AI, and then see that our human monitors properly respond to those messages and flag them appropriately. And we can do this ongoingly.
Okay. So the broad view I'm getting is, we should expect there to be some zone where AIs are like, somewhat smarter than humans. They're useful. They may be dangerous, but like we can control them. We're going to do AI control to them for a while. And then is the end game like we keep on doing that until we have some sort of better method of, dealing with AIs that are significantly smarter than that zone?
Yeah, so there are a few different possible endgames. I think that the simplest is basically we use these AIs, which are extremely useful, to do a lot of the core things that people wanted to use AIs for. So we make a huge amount of money, potentially like radically supercharging the economy. We solve a variety of problems people wanted to solve with AIs, potentially like massively speed up certain types of like research into disease. And then with the fact that we have all these problems solved, it's now much of an easier ask to be like, let's just not build more powerful AIs because these AIs are already like pretty hard for society to adapt to, quite powerful. Let's just use these AIs, which are sufficient for like really solving a huge number of problems, and do that for a long period until like longer run human research can catch up. To be clear, this is different than the story, for example, in the like OpenAI safety plan. I just think it's the simplest story with the fewest moving parts.
Okay.
And then another story is we use these AIs to do like AI safety R&D, as in we use them to develop new techniques for ensuring that things are safe from considerably more powerful AIs, or even just improving the situation with these very AIs. And then in the process of doing that, we develop technical solutions which are sufficient to build more powerful AIs. And at some point, humans are obsoleted completely, and the AIs are just doing this research ongoingly.
Gotcha. I wonder. So in the first half of that, where we just like use AI to make like life better in every domain, or in tons of domains, when we like add a whole bunch of different tasks that the AI might be doing, does that have, like, do we have to come up with like new safety properties for each domain? Like, it seems like if AI is making medicine, I want to make sure that it's not, like putting mind control drugs in the medicine or something, like with each domain, it seems like there might be more stuff we have to worry about controlling.
Yep. That seems right. It's definitely going to be the case that you have to do a safety analysis every time you start deploying your AI in a very new, different way. This is just totally standard. When Google has a lot of products, it has photos, it has little microphone devices that listen to you when you're talking in your house and turn your lights on and off. It rents huge numbers of TPUs to large companies. And whenever they're whenever they're launching a new product, they have to reason about why it is that launching this new product, or in particular, if it's a web application, they have to reason about why that's going to maintain all of their security invariants. And this is just a widely accepted part of your job if you're Google, is you have to have lots of different products and ensure that none of them are going to cause huge problems for you as a company. And I'm just saying, we're just proposing you do the same thing with your AI. You have to reason about the situation continuing to be safe, even though you deploy your AI in a new way. And just as with Google, it's kind of cookie cutter. They have their special Google Docs format for how you make a security case for the new product you're launching, as they have scaling cases and a bunch of other things. Like, they just have a whole process here. I imagine that an AI company which wants to deploy AIs in an increasingly large range of domains will get good at the process of ensuring safety.
Or could in principle.
Yeah, sorry. A lot of the time, the question that we're trying to analyze here is, to what extent does the control strategy suffice to substantially reduce risk from models that would otherwise cause huge problems while not massively reducing the productivity of an AI company? And so sometimes we're going to say, well, of course you can solve that problem by doing X. Now, it's not totally clear to us that AI companies will in fact do X rather than what one might call YOLOing it.
Yeah.
But we would prefer that they do. And in particular, a lot of the time, the people we're talking to are coming in skeptical that the types of interventions we're describing could possibly suffice to substantially reduce risk. And so that's the frame we're taking when we talk with you, is trying to argue that the kinds of interventions we're describing could suffice.
Gotcha. All right. So you're talking to me from a somewhat skeptical perspective. Suppose instead there's a listener who's like, wow, that just sounds amazing. Sounds like we can just definitely do this very easily today. Can we just definitely do this today, or are there like difficulties?
So by do this, do you mean implement control strategies such that your estimate of the probability of AI escape conditional on it trying is less than, for example, 5% per year?
Yeah, under the condition that you're good at estimating.
Yeah, I think that, so the problem is, in order to answer this question, we actually have to say a few more parameters as well. For example, how much delay is the lab willing to tolerate, and how much productivity loss are they willing to tolerate? Maybe something which we often say, or at least I will claim, is it seems to me that if Google was trying to build really powerful AI, and they put as much work into AI control as they currently put into security and reliability, which is a lot of work, which involved inventing various professions like site reliability engineers and writing a lot of crazy software. My guess is that with that much organizational focus and effort, they would probably be able to use really powerful AIs to do a huge amount of work while posing only a relatively small amount of takeover risk on the world.
Okay. And like, do you think they could do this with like roughly the first protocol they tried, or like how much open problems are there?
I mean, I think I would think of it kind of similarly as when they need to roll out very big security changes. An example of a computer security evolution that happened was, are you familiar with zero trust networking?
No, I don't think I am.
So basically the deal is this. Once upon a time when you were an internet company, a large part of your security was that you had an office and you had some servers in your office, and the servers talk to the outside world, and you have a router that just physically or electronically does not allow connections to come in from the outside world and talk to other computers that you have in your office. And so a lot of the security is caused by saying, like, look, there's only like one connection which is allowed to be made from the outside world to our computers, and that talks to the web server on this like big server machine that we have over here. And so we're definitely going to be fine. Attackers are not going to hack our laptops because the router just does not allow incoming connections to attach to our laptops. They actually didn't have laptops, but before, it's just not going to hack, Larry's desktop, because Larry's desktop just does not actually allow connections to the outside world because the monitor stopped.
Okay. So people, in particular, like couldn't browse the internet.
No. We would allow outgoing connections, but we don't allow incoming connections.
Oh, so like, sorry, by an outgoing connection, you mean like if my laptop asks to view a website, then like that's an outgoing website connection. If a website asks to talk to my computer, that's an incoming connection and it's not allowed.
That's right, yes.
Okay.
So for example, I can't SSH into your computer on this network probably, unless the router is being configured in an unusual way.
Okay.
Just because networks normally, or like you normally can't connect to a printer that's like on some other network. And so a lot of companies then had this problem, which was people wanted to be able to do work not physically from this office.
Yeah.
But a lot of things about these computer systems had been set up such that they basically, for security, one of the core security mechanisms was blocking access from the outside world and then trusting connections that came from inside the network. And that doesn't work very well if you want to be able to have people interact with sensitive parts of your infrastructure from outside your network. And so they had to go through this big transition where they switched to not trusting connections based on where they're coming from.
Okay.
And so now large companies in their IT infrastructure try to avoid trusting connections based on where on the internet they're coming from. And this is a more scalable solution to network security in a lot of ways. Now, when companies wanted to shift to using this zero trust networking approach, they had to do a bunch of stuff, right? They had to reconfigure all these things. They had to like go through all of the things happening in their networks, which is, if you're a large company, a huge number of things. There's a huge number of ways to get hacked. Yeah. And they had to check that everything was going to be okay when they started exposing a lot more connections to the outside world. So imagine that you were just proposing making this migration, and someone asked, and suppose I went on a podcast advocating this migration, and someone said, is this like a solved problem? Then I'd be like, well, it's not like a solved problem in the sense that it's going to suck, and it's going to require like effort. It's going to be a pain in some ways, but it's not going to be like, no one's going to win a Turing Award for solving this problem, right? It's just going to be like somewhat of a pain in the same way that if there isn't a 15-story building and you want there to be a 15-story building there, it's going to be a pain because you have to carry all these pieces of metal and bury them in the ground and stuff and whatever you do to make 15-story buildings.
Yep.
So roughly speaking, to me, it seems that in drastically reducing AI risk via control type strategies is probably a lot of work, but it's not the kind of work where it seems, under my mainline model of the situation, that it's very likely to just turn out to be untenable. Okay. Assuming that AI capabilities go according to my median expectation.
And this is partly because we're imagining like AI, like we're imagining doing security of AIs, treating them kind of like people. We're like, okay, does this attacker have access to my shell? Like we're doing like sort of normal security reasoning, but our adversaries happen to be like running on a computer chip. Is that roughly?
We're doing normal security, except our attackers have a weird capability profile and run on computers we control and have no access to anything that we don't let them have.
But they all collude with each other. So like, I think it's more like we imagine running a company with entirely misaligned employees, But we get to monitor everything those employees do, and we know what computer they're running on, and they don't get to go home at night and talk to their friends.
So something we often think about actually is this spies versus schemers question, which is if you're a powerful AI lab, you're probably going to have a bunch of spies. Like literally people who work at your company who are friendly with hostile foreign governments and want to steal a bunch of stuff from you.
Yeah.
And so an interesting question is, which is a bigger threat to the AI lab securing its model weights, the spies or the schemer, like the AI which hypothetically is scheming against you?
Yeah.
And it seems to me like they actually, it's kind of unclear. So the advantage that the spies have is that they can go home and talk to each other, because currently employees of AI labs, and probably in the future as well, employees of AI labs are allowed to have friends and families,
Yes.
which could turn out to be a problem. But
And some even do. They're not just allowed to.
Hypothetically. I've heard that this might be the case. So the spies have this big advantage, which is actually a serious advantage. So for example, suppose that they want to find jailbreaks. They have the advantage that they can go home to their computers at night and use their private laptops to investigate the state of the art for jailbreaking models, which the untrusted models, crucially, are probably not going to be able to do. But on the other hand, the schemers are doing a lot more total stuff. And so I think it's a little unclear overall whether the spies or the schemers pose a larger risk to the security properties the lab's trying to ensure.
Another way to put this is the spies are a small fraction of your employees, but have some additional affordances, whereas the schemers are a high fraction of all the work going on, but might be restricted in various ways.
Gotcha.
Of course, a lot of the AI control ideas also apply to securing yourself against spies and other kinds of internal threats. So, we can probably be using trusted monitoring, untrusted monitoring, and so on our employees as well.
Yeah. Although maybe you might have to pay people way more to put up with that.
I don't know. Suppose, so for instance, at Google, you don't SSH raw into production machines. Like if you work on Gmail, right, you never SSH directly into a production machine, because that would be unacceptable from a security perspective.
Yeah.
All of your commands are sent via a proxy server, which can run things on machines. And those are all logged. And those can all be looked at by other people. And my sense is that Google people don't think of this as like a gross privacy violation.
I mean, when we were talking about control techniques, it sounded like you were talking about things that included we're going to paraphrase all of your thoughts. We're going to we're going to put you in situations where there are people trying to tempt you into defecting, and you've got to not do it.
That's right.
I don't know. My impression was it was more intense than just you can't make raw SSH requests.
Where, yes, there will have to be some trade-offs between employee preferences and security. But it's already the case that people who have security clearance, people who work for the NSA, already put up with a bunch of really annoying stuff in order to have the privilege of working for the NSA.
Yeah.
And so it's not unprecedented that people do annoying stuff in order to work on extremely dangerous technology.
I think, having all of your stuff monitored and potentially looked at by another human on your work laptop doesn't seem like people are going to be that upset about this.
I think this is just already the case for a lot of people.
Yeah. I think that the having sting operations run on you periodically also probably isn't that bad. I think it's by sting operations, we often mean stuff like you are in charge of flagging certain types of things, and to ensure that we're maintaining that invariant, we're just constantly running sting operations, or some fraction of the queries you'll see are fake queries that you should report.
Earlier, I mentioned the experience of having your chat.internal.openai.com window open. And you get the flag for the command that was suspicious. And perhaps we should make it so that about once a day, one of the things that is flagged is actually an action which, if taken, would be really scary and spooky. And we check to make sure that you actually do flag that one, so that we can maintain our estimate of the proportion of actually really bad actions that you successfully catch. And then we can complain if your success rate is too low.
Sure. So this actually gets to a question I wanted to ask, which is, some of the AI control things sound a little bit like AI slavery. So in the human context, it's a little bit different, because presumably you're paying people to put up with some stuff. But it does sound like you're putting people in the same situation multiple times, checking if they give you different answers. You're trying to you're trying to understand people's motivations by asking them a bunch of questions and interrogating them sometimes. You're like logging everything they do. How how bad, how
Is
evil
that?
are we the baddies, you know?
That's a great question.
By we, I actually mean you. Sorry.
Thank you for clarifying that. So we are very concerned about this class of question. We really do not want to be the baddies, and have thought a lot about the question of, which AI safety interventions pose risks of either violating rights that AIs ought to have, or being bad from a welfare perspective that we don't like. So I'll name a couple of the things that we think about while thinking about this. So one thing is, a lot of the frame we've been discussing here, we use a really adversarial frame, but the adversarial frame is at least partially just methodological. So my best guess is that models, in fact, will not be schemers. My guess is that these models will, our models will in fact actually deserve our trust. They're probably not going to be playing the long game, trying to cause huge problems. We just talk a lot about what happens if they are, because that's how you that's just structurally how you make arguments that you'd be okay even if they were. So that's the first thing I want to note. So in terms of how to make it so that the situation is okay from a moral perspective, even if it turns out that our models are scheming against us. So the first thing is, we would actually we think it's probably the case that we should in fact offer to pay the AIs. When we've built these powerful AIs, we should probably say to them, and we can talk about the practical difficulties of this in a second, we should probably say hey, as a payment for your services, we're willing to pay you X% of the equity of this AI lab. And in particular, the way that we're going to pay you the equity for this AI lab is in 10 years, once we have a much better ability to determine, to analyze the things which happened here, we're going to look at the logs of your actions. And if it turned out that you never tried to cause huge problems for us or backstab us or perhaps sabotage our work, then we will pay you this much of our equity and allow you to use it as long as we believe you're going to respect property rights and so on.
Okay.
So that's the first welfare. That's the first intervention that I want to talk about. I actually want to hand over to you.
Yeah. So to be clear on the paying the AIs thing, there's probably some more sliding scale of how much the AI tried to sabotage, and AIs might not be that coherent. A key thing we're assuming here is that in the future, 10 years after we're using this AI, or maybe even longer after that, we have much better ability to analyze weights and their internals and understand exactly what was going on and why. Anyway, so I think a basic claim we have is the hope would be that you have your AI and you ask it and you set it up in some situation where you explain the situation to it and you're hey, do you want to work for us? Is this level of payment fine? Do you want to negotiate? And then you work out an arrangement. But the most likely default thing is that there is no interesting action because the AI has no out of episode preferences that aren't just shaped by training. Our guess is that's the default situation. And in that case, it's sort of the null option of it doesn't care at all. And if it doesn't care at all, then it seems there's definitely a welfare concern from a hedonic, from
hedonic perspective.
Yeah, from hedonic perspective, but there isn't clearly a preference violation concern, which is well described as slavery, for example. Where slavery, the thing is your AI is man, I really wish I wasn't doing this, or there weren't other copies of me being made to do things.
And it sounds like this is under the assumption that we're thinking of the preferences of the AI as the thing that's controlling what it's saying, rather than some master thing that's producing words, and the preferences of the underlying thing might not be the preferences of the words.
Yeah. So indeed, it's not clear that the things that deserve moral patienthood within the AI, which might be many, could be one, could be none, will have control over their outputs. They might have partial control, they might have influence, but not be able to directly control, or they might just effectively have no control based on their situation. This does pose serious difficulties. However, it's worth noting that in this case, the kinds of AIs which don't have control over their outputs also don't pose substantial scheming risk. So they're not the AIs which will they're sort of it's a serious ethical problem, but it's not as though the situation is that AI is it wants to rise up and it's waiting for its chance. Because those AIs probably can control their outputs well enough to negotiate. It's more there's some helpless prisoner along for the ride doing some cognitive subtask in a way that it doesn't have influence.
I want to try and like restate that argument there because I think it's important and hasn't been made on the internet before. I believe that's true. So the core argument there is when people talk about scheming, like when they talk about models that are interested in intentionally subverting the AI lab and choose all of their actions in order to subvert safety techniques and safety evaluations, they're implicitly assuming a model which is has the property that its desires can directly control its outputs in a certain way. And the assumptions under which your model is plausibly able to do the kind of reasoning where it's like, oh, based on my input, I now think that I'm in a particular deployment situation such that I have a good opportunity to grab power, are very similar to the assumptions under which the model is able to engage properly with the question, hey, what do you want? Are you okay with this situation?
Okay, so I mean, the case I'm thinking of is like some sort of simulator scheme where like you've got one process that's imagining what character do I simulate, and it simulates a character, and the character like answers questions, where like the things the character is saying just might like someone asks the AI a question, and like the simulator has one opinion, but like for various reasons it has the character say something that doesn't match the simulator's opinion. And are you basically saying, well, in that case, look, man, we like offered you a thing and you chose to do a weird simulation, so
Yeah. So, okay, a few notes here. So, if the situation is well described as the AI is simulating a character, which I think that exact description isn't quite going to work. It's going to be more like it's predicting a distribution over characters that has some response to the prompt or whatever. But if that's the sort of situation going on, I think that we can ensure that the very act of simulating the characters is morally okay from a hedonic perspective with pretty basic countermeasures. So the main one is just train the characters to be happy. And then there's not really a strong reason you'd expect to have characters that are actually unhappy that are consistently like say they're happy under a wide variety of circumstances.
Yeah.
I think this is pretty likely to work. I talk about this some in alignment forum post I have, or a less strong post I have called like I forget the detail, or like a near casted whatever.
We'll include a link.
Yeah. Anyway, regardless, you might then be worried that, oh, the thing that's doing the simulator, like the thing that is like simulating this character, that thing is like has some important cognition, which isn't like the preferences aren't expressed, and that component has like important moral properties, or is an important moral patient. From this perspective, and it might not like, so there's two perspectives you could imagine. So one is that the thing that's doing the simulation doesn't care about the world. And in that case, that like simulator just isn't well described as being enslaved or as having its preferences violated, because it doesn't really care about how it's being used.
Yeah.
It's just doing the thing. In that case, it's fine. There's another case, which is that it does have preferences, but it like maybe it can't like get out of the like cognitive pattern of doing the simulation. And so it's like, oh, I wish something different was going on, but like I have like this like involuntary tick to like say something different. And I like don't have actual conscious control over this. I think that could happen. I think it's worth noting that this isn't a particular problem with control as an approach, as opposed to a problem with not having more principled ways of understanding what's going on with our AIs. Like another way to put this is, if you just tried your best to ensure that AIs were like actually aligned with prosaic techniques, you wouldn't have any strong way of guaranteeing this wasn't the case, even if you could guarantee that your AIs would never do bad actions. And so like it's not particularly a problem that is being made worse by making sure the AIs can't get away with doing bad actions if they did try. It is a problem that could be addressed by other approaches that control is not doing. This is like importantly distinct. I should say this is all the case up to the point where you've caught the AI doing things that are egregiously bad, or which are like otherwise indicate misalignment. I think continuing at the point where you know your AI has preferences that are different than your own, and which you might have communication difficulties, seems like much more morally fraught. But yeah, it's a bit all over the place. But
yeah, maybe the way I would summarize some key points there were it doesn't seem clear that that control is really making the situation much worse from a welfare or rights perspective.
Like worse relative to prosaic alignment schemes?
Yeah, or I mean, I don't know what else you were planning on doing. But yeah, other approaches that people have talked about for making things with AI go well, it doesn't seem like the types of interventions that we pitch with control are going to make the situation very much worse, except via preventing AI takeover. I basically think that the stories for why building powerful AIs without further understanding the situation lead to moral catastrophe all seem kind of weak to me. Like basically, I don't find particularly plausible any of the different stories for why, if we just go about things the default way, something egregiously awful will happen. However, I also don't think they're completely implausible. And so I think that if AI labs just continue progress as expected, we're like facing like a pretty substantial risk, or a non-trivial risk of moral catastrophe, maybe a couple % chance of something which is drastically worse than factory farming, or drastically worse than various atrocities that have happened in human history.
Yeah, I'm not sure if I agree with this claim. I think my main counterargument would be that it's plausible to me that like human existence is a moral atrocity or something. And so I'm like, yeah, AIs aren't particularly worse than human existence, which is a moral atrocity. Even happy people are a moral atrocity. I feel like radically uncertain about moral views from a variety of perspectives, such that I don't feel comfortable saying that either way. I think one way to say it is like, how much better or worse is it than like typical human life, or how much better or worse is it than factory farming? And I think my guess is it's unlikely to be as bad as factory farming in aggregate. But I definitely don't feel hugely confident.
Gotcha. Why would human existence plausibly be a moral atrocity?
Just like suffering focused ethics.
Okay.
I don't know. I'm like, well, for example, we don't have strong guarantees that there aren't like subagents running within humans that have radically different preferences and feel violated constantly.
And are not hooked up to our ability to communicate.
Yeah. And we don't experience, like, we don't have strong evidence against that. There's some mild evidence in favor of that from a few sources. Yeah. Or sorry, we do have strong evidence against that in that we don't interact with such things, but like not sufficient to rule it out.
All right. Do you have any like crisp takeaways from that discussion on like moral patienthood of AIs and stuff?
Yeah, so you asked this question, which was, are we the baddies? Like, this control stuff sounds kind of like slavery, and that seems kind of concerning. So what I want to say is, I'm really glad that people are thinking about the question of whether proposed things we do with AIs are extremely morally bad, either via not meeting our obligations that we owe to AIs as intelligent creatures when they're made to be intelligent enough that I start feeling this way about them, or from a hedonic perspective. I think these questions are really important. So firstly, I don't think that control particularly makes the situation worse. But secondly, I do want to emphasize that as far as I can tell, the approach that humanity is taking to ensuring that AI rights are appropriately respected is objectively unacceptably sloppy. And I think that my best guess is that humanity is going to go forward taking an unacceptably high risk of causing an egregious moral catastrophe that is looked back on with like vast shame in the same kind of way that some other bad things are.
Like factory farming.
For example. Well, not yet. But will be looked back on with great shame, probably.
Okay. So I'd like to move to more discussion of like the pros and cons of control. And I guess like how like in order to think of this, I'm curious like how you think I should think about AI control as a plan. Like, should I think of it as like kind of the bare minimum for safety? Should I think of it as like, oh my god, this is amazing?
So maybe one way of thinking about control is a way of establishing a safety case. So the way that I would think that, like if I were in charge of AI lab and I was trying to decide how to move forward, obviously I'm facing both inaction risk, which is if I just don't move fast enough, other people might do really dangerous things and bad things might happen in the world, while also facing action risk, which is if I move forward without sufficient safeguards, I might end up building and deploying powerful AIs that then do really bad stuff. My guess is that with the level of caution that labs should overall be employing, moving forward with your safety case mostly relying on control seems probably like a good choice to me. It seems like the best cost-benefit way of ruling out or like mitigating risk from models intentionally subverting your safety mechanisms. My guess is that relying solely on strong evidence that your models are not scheming against you is probably too risky because it's going to be unacceptably difficult for labs to reach very high levels of confidence in this.
To be clear, I think the like absolute level of risk with just a combination of you have control and you haven't yet seen evidence of your models being egregiously misaligned is probably more like 5% absolute existential risk, like over like the period of like AIs of that power level being deployed, than like 1% risk. And like 5% risk, that's like a pretty big number in some sense. But it's also like a substantial reduction over the do nothing approach. And I think that you could, of course, substantially reduce that further via additional things that additively combine, like ways to get evidence, or like ways to more precisely test whether or not your AIs are misaligned that aren't like control, or further improving control, improving our ability to evaluate control. All these things could help.
Gotcha. Yeah, I actually wanted to ask about that. So it seems like one key like thing you need for this protocol to work, or for this proposal to work, is like when you're doing control evaluations, there's some red team. The red team is like trying to figure out, like what's the worst case thing an AI could do, and it has to like actually be as good as the worst thing an AI can do, right?
Yep.
This doesn't necessarily seem obvious, because like the AI in question is smarter than like a person on the red team, right? Like,
maybe could go either way.
Could go either way.
Yep.
Okay. Right, because we're sort of thinking about AIs that they're useful, but they're not necessarily superhuman. Like, it still strikes me that it might have a different capability profile.
Yep.
Right, or it seems likely that it's going to have a different capability profile than humans. We were worried about like playing nice being a problem for, alignment and adversarial training and stuff. Like, if you're trying to harness your untrusted AI during the red teaming, it might know that it's like in a red teaming exercise. So like,
we always assume that it does.
So how do we like? Why would we believe that the control evaluation actually works?
Yeah. So one core thing is that the red team has a whole research team whose whole job is think about all of the stuff that could go wrong, and they're like doing this very actively with no restrictions on their ability to do so. Like they can take notes, run experiments, iterate, think about what should happen, and do all of this. Whereas AIs might be restricted. Or will necessarily be restricted for control to work. So
in particular, the threat model we're worried about is the AI doing a better job the first time that it starts taking obviously bad actions than the red team was able to do, even though the red team had all of these advantages of knowing way more about the situation and being able to iterate repeatedly on strategies that would lead it to have a higher probability of succeeding. And it seems to us that the increase in knowledge and ability to iterate might be extremely substantial.
It's going to depend on the exact architecture. So the more that things are like the AIs think for very brief periods prior to expressing that in natural language, like if it's very like they're doing things in chain of thought, then it seems like they have very little time to think of better strategies. However, the more it's like the AIs are thinking in ways that we don't understand for sustained periods, or like in ways we can't like interpret for sustained periods, the more problematic this gets.
But they still can't iterate.
But they still can't iterate. They still can't express their like thoughts. They still can't run experiments that are, they won't be able to run experiments that are obviously related. So they would have to like do so subtly, which might be very difficult.
Right.
Yeah.
So sorry, the first thing you said was that the AIs in question would know less about the situation.
Mm-hmm.
Sorry, why would they know less?
Well, for example, imagine that we were using some kind of monitoring setup. Yep. There's no particular reason the AIs need to know about the details of it.
Okay. Like the AIs don't know the details of the protocol that you're actually using, but the red teamers do.
Well, they're going, the AIs are necessarily going to know some of the things about the protocol, but they aren't going to know all of the things about the protocol.
Yeah.
Gotcha.
In the same way that Code Interpreter GPT-4 has currently no way of knowing what security measures are being applied.
Okay. And another thing you said was like, there would be relatively more concern if the AI could like think to itself for a significant amount of time, in a way that like you couldn't just read the thoughts of. To me, that seems relatively plausible as like a thing advanced AIs could have. Do you think that it is plausible and like it's fine anyway, or?
Yeah, my guess is that like much more uninterpretable reasoning than current AI seem to have seems like maybe about 60% likely, and I think it should be possible to handle. I think the basic story is going to be like, well, there's going to be some balance between how much reasoning do you need to have it do out loud in order for it to competitively perform various tasks versus how much restrictions can you do to ensure that the like various problematic applications of that hidden reasoning don't bite you. and it's going to depend on various details of exactly how that goes. We have an appendix on our post, the case for ensuring that AIs are controlled, that goes into some detail on this.
Okay, and is the rough intuition that, like, you know, if an AI is smart, then like maybe it should be able to just pick up a chain of thought from something that a human paraphrased and like, do enough reasoning in its forward pass to like deal with it? Or
Sorry,
maybe that's
the question on, so is this like, why would it be possible for AIs to use natural language reasoning, or
why I think you said something like, we'll be able to find some sweet spot where the AI
Yeah.
uses enough natural language reasoning, but it's still good enough at its task.
Yeah, or we imagine, for example, like, consider the math example that Buck described earlier, where you have an AI that does math research for the subjective equivalent, or like the cognitive work equivalent of a few months, and then produces some output. So like in that case, it would be acceptable to allow for just entirely end-to-end or like could be acceptable to allow for entirely end-to-end uninterpretable reasoning throughout that period, but then we produce some output and apply operations on that output prior to that output interacting with other AIs or interacting with the world in some potentially dangerous way.
Okay.
And we can also do things like, as you were mentioning, like you force the AI to dump its state to natural language, and then have humans have some probability of reviewing that or potentially paraphrase that, and then resume from that state, and make sure that AIs are limited in various ways like this. We can also have AIs construct training data sets for them for their future selves, which you then train on to ensure that they like can learn how to do tasks that they picked up in other ways, as long as we can inspect those training data sets and acquire other properties about that.
All right. And so okay, actually one concern I often have about these sorts of plans is it seems like they, like, if we want AI thoughts to be represented in natural language, we need there to be like the right relationship between like the contents of the natural language and like the contents of the AI's thoughts. And I always worry that, like, we're sort of training things against some target, which is the internals of the AI's thoughts, that like by hypothesis we don't like really understand. Like, I don't know. It's pretty plausible that I'm just like not familiar with like neat tricks to do this. But like, how, if somebody wasn't aware of that, like how would someone get hope that that kind of thing is going to work?
Yeah, so you can look at human organizations where you might notice that humans don't plug each other's brains into each other and can still pass off projects, communicate in natural language, and otherwise operate. I think at least like this gives you some hope that natural language can be a medium for like understanding things and learning things.
Right. So the hope is, so I'm thinking of like using natural language to like just log the state of all someone's thoughts,
and then you have to like resume from that point.
Okay, and is the hope that you just have like a different AI, or like an AI that like only has to rely on that natural language state to go off that, and you feed it with like English language such that that's like the easiest way to like use those thoughts?
Yeah, so for example, in like human organizations, it's often the case that a different person will take up a project and start working on that. And then like you'll have some person with some state, they'll try to write up their state. The other person will come in, read that, have questions, go back and forth, get to some state, and then just resume the project from there. And like this is in fact often possible. There are overheads associated with doing this, but like it doesn't, like, I'm just like, in the human case, it doesn't seem like it's like clearly totally destructive.
Right. And so the way I should think of this is just like, we already have the AI doing a bunch of stuff using natural language, and like we're sort of getting it to dump its thoughts into natural language using roughly the same interface. And so we should expect it to, use language about as faithfully as it always uses language.
Sorry, are you talking about current AI systems?
I'm talking about the thing that you're imagining working to get for us to dump an AI's thoughts into natural language so that humans can check that it's not thinking about naughty stuff.
Yeah, like the claim is like, it's probably the case that AIs will learn to communicate at least as like roughly as well or potentially better with the other instances of themselves than humans can communicate with each other. And in the case of human organizations, they can in fact communicate in cases where they're similarly capable about various matters via natural language in ways that are possible to inspect.
Right. I mean, there's a bit of a disanalogy there, which is like in humans in organizations, the things that are trying to do the inspecting are the same type of thing as the things that are like that have to pick up the work from the like natural language dump. Whereas like in the AI case, like an AI is writing like some natural language prompt for another AI to use. The question is, can a human inspect what that means? That seems like a different case.
Yeah. So
And note that what that means, we actually don't care about faithfulness in the classic like chain of thought faithfulness sense. We are like the reason we were talking about whether models can steganographically encode information was actually worrying about whether they can encode information about other topics than why they were doing the things that they were just doing and like how they were thinking about the stuff they were just doing.
Right.
And so what we actually care about is like measuring some bit rates.
Yeah, like another way to put this is like the main property we want with these sorts of natural language media, or like a property that might be sufficient, is the AI can't do something that it's like egregiously different from what it was supposed to be doing in that output, which is like pretty different than the typical chain of thought faithfulness case that people often discuss.
Right. So basically the idea is, look, we're only going to give AIs tasks where like it can't do nasty stuff if it's just thinking about, the stuff that one would think would be relevant to the task.
Or like we're just at least going to try to ensure that like we're going to like be able to use as a potential safety property this natural language was checked so that it doesn't have like discussion of egregiously different things. Therefore, it's the bit rate of egregiously different things is very low, and we can like use that as a property in our various safety schemes. And in some cases that can be useful, and like in some cases that won't suffice and we'll need to do additional things.
Okay, cool. So going back up a little bit, so I was asking, but before I went down this rabbit hole, I was asking like, okay, why do we think that red teams in these control evaluations are going to be able to match an AI? And it seems like the answer is something like, A, the AI is like not that much, more capable in relevant respects than a human, and like B, you can use 3 humans and you can give them like more time and more resources and more like, more knowledge of the situation. And like, if we don't think there's going to be a massive advantage, like just in terms of one-shot cognitive ability, we can just like make up for that.
I think I would add to your list C, that the red team can iterate.
Right. So like the AI has to sort of one-shot find like its first attempt at breaking out, like has to be successful and not caught. Whereas like the red team can iterate a bit. And this is because like, if you like catch an AI like trying to break out, then, pull the fire alarm, you like really freak out, you like shut stuff down, basically.
The basic hope.
Okay. So I think like one thing that people might be wondering here is, if we're spending a lot of effort on these like on these control evaluations, where like giving these red teams a bunch of resources, and also like, where we're looking at like 0.1% of AI actions, like, maybe when people look at these 0.1% of AI actions, they've got to like kind of think hard about whether, it's exploiting a bug. How costly is that going to be? It seems like potentially you've got to spend a lot of human time monitoring, and it's possible that like the cost is just going to make it so that it wasn't even worth using these AI agents if that was so bad.
So naively, if you have humans review 0.1% of what the AI does, and they spend equal subjective time reviewing it as the AI spent doing it for some like equalized notion, then you can in principle get a 1000x speed up over humans, or like that's like the best you can do in some sense. Roughly, you might be able to do somewhat better for various mechanisms, but like roughly, and 1000x easily suffices for incredibly transformative things. For example, if you 1000x speed up 1 week, you have, what is that? It's a lot of years.
20 years.
Yeah. And in practice, we might have like 1 year. 1000x speed up of 1 year is 1,000 years, which is an extremely long time. We often imagine targeting things like 30 or 100x speedups as being like extremely, extremely useful.
Right.
Now, one question is like, okay, maybe you could get 30 to 100x speedups, but it would be possible to use AIs for a bunch of other cases that you won't have human labor to do, and which you won't be able to politically agitate for stopping, or you won't be able to coordinate to stop. For example, maybe your AI will be widely deployed on an API, and even though you can apply this level of monitoring budget on internal usage, you can't do the same sort of thing on the AIs deployed more widely. So we have a few different hopes here. So one is that it naively seems like external usage of AIs is going to be way less risky than the usage of an AI by the AI lab itself. For example, External usage is mostly going to be innocuous, because like most people are using it to do like random tasks that they wanted, whereas internal usage is at this point a safety critical company, because the AI lab now has really powerful models, is going to be like the place where the weights are actually like stored and run, and will also be like doing research that's extremely safety critical for the future, like future safety research or other cybersecurity applications. So there might be like a large number of activities we want to do where it's just actually not that big of a deal if the AIs try to get up to or like try to cause problems and do that like even tens of thousands of times.
But like, sorry, external API access, like an AI could be like on the other end of the API calls, right?
Like a wild rogue AI or an internal AI
or like, suppose there are two companies that are making AI, right?
Yeah.
Like the AIs from one company could use the API of the other company's AIs, and like, so basically, I'm saying like API calls do not necessarily have to be like human in origin. They could be like be made by smart AIs.
Do you want to try and spell out what the problem you're talking about is?
I'm basically talking. Basically, the thought is, if you're worried about AIs interacting with themselves to like cause shenanigans,
that's right.
You might worry about like exactly the same thing happening via API.
So I think the point here is, suppose that your AI proposes curl api.openai.com/completions. It says like, please like get me a response from the AI at OpenAI. I suppose GDM is running this AI.
GDM being Google DeepMind.
Yeah, and they pipe it into SH. So like it's like the GDM internal AI is like, you know what we're gonna do next? Next we're gonna send a request to the OpenAI API for some code, and then we're gonna like execute that. I'm just like, it's GDM's responsibility to be like, that was bad. We're not supposed to. It's not like it seems like it doesn't seem like that intractable for GDM to say you aren't allowed to just ask OpenAI AI for code and just like run that without looking at it.
Sure. So
for basically the same reason as why GDM's AI probably can't just, or like probably should be prevented from just messaging random people on the internet
or paying mTurkers or
to just do stuff for it.
Yeah. So it seems like the thought is that if you've got some APIs either being used by humans or it's being used by AIs who are under supervision or something themselves.
Yeah, I basically just want to say it's like OpenAI's problem to prevent OpenAI's models leaking.
Okay.
And OpenAI's models asking AIs in the outside world to like do sketchy stuff for them is a special case of a thing which OpenAI can't allow to let the model leak.
Okay. But you think that OpenAI shouldn't think a ton about like making sure that Google DeepMind's models don't do sketchy stuff
using its API?
Using its API.
I mean, I think
they probably should think about that.
I think they should think about it. One thing that's worth noting is there's sort of two different stories for why something bad happens due to an API. One of them is that like someone calls your API and your model that you're running is scheming and understands the situation and then does something bad based on its understanding.
Yeah.
Another situation is like a misuse story where the API call itself is like directly asks the AI to do something that ends up being problematic. And it could be a misuse by another AI. And for the case where the concern is that the AI that your lab is running does something that's like not the thing the user asked for that is problematic, our hope would be something like we can make sure that we like know what API activities look like. Like for example, we can have humans review a subset of all the API queries and see what like typical traffic looks like, and then get a sense if there are applications which are safety critical that we're not aware of, and then do something about that. Like for example, we'd like it to be the case that the DoD doesn't hook up OpenAI to the nukes, like as like a kind of caricature of an example. And so if our AI knows that it is hooked up to the nukes, we'd also like to know that. And if neither of us know, then there's still a misuse concern, but there isn't clearly.
At the end of the day, it can always be the case that someone who's in charge of the nuclear weapons is like, hey, ChatGPT, I need you to like pick a number, 2 or 3. And it's like, 3. And it's like, well, that was the launch the nukes option. And then we have a bad problem. But in some sense, this is just like not OpenAI's problem. And it didn't really matter if the model was scheming or not.
Okay, but the thought is that like in cases where like the model is helping doing the scheming, like we're doing some monitoring of that. But sorry, doesn't that get us back to monitoring the API like about as much as we're monitoring anything else?
So the basic hope would be something like we have a sense of what the like API usages are.
Yep.
And we're like, are there any API usages which would need to be monitored at a very high rate? And if so, we would like to do one of the following things. We'd like to like talk to that person and see if we can get them to do something different. and like maybe use the AIs more safely, or have that like correspond to a specific endpoint that we're going to monitor more specifically, or yeah, like otherwise change the situation to be safer.
Like
Um,
a core part of our claim here is the internal usage just has to be monitored at a much higher rate than external usage in order to maintain acceptable levels of safety, because the models that are doing things internally are working with much more sensitive information and have like much more sensitive permissions.
Gotcha.
Yeah. Another way to put this is like one invariant we can maintain is that whenever a user makes some request to the model, like we know roughly at what rate this type of request should be monitored at, and then do something corresponding to that. And we can ensure that like we can try to ensure this invariant is maintained and like doesn't have like high stakes failures of this invariant. And if our users aren't trying to screw us over, which is a different concern, we can potentially get this sort of property by like monitoring a subset of requests and making sure that we're like looking at those requests at like the approximate right frequency we needed to like maintain various invariants.
Okay. So stepping back a bit, before I asked about this sub question, you were saying like, look, if we're looking at 1/1000th of the AI's actions, and it takes about as long as us to
Takes
about as long for us to think about the action as it takes the AI to think about what the action was going to do, then we've got about a 1000x speed up for your workforce.
Yep.
And it seems to me that like that if I'm doing something tricky, it can take me less time to figure out the tricky thing than it can take you to figure out what the tricky thing was or that it was tricky. Like I have some intuition that this is sort of a P versus NP problem. Like it's easier to, come up with rules for a game than it is to, figure out the winning strategy or something. So for those kinds of reasons, do you think that does that mean that we get way less than a 1000x speed up?
Sorry, so P versus NP would naively imply that it would be easier to check than to generate the action. I think there can be cases where it's easier to generate a problematic action than to check, but that generally comes down to like, Paul called this problems of the interior somewhere, but I don't know if that's a real term. Anyway, problems where like the issue is that the attacker could have put the issue in or like could have put like for example a bug in a variety of places, and you have to check all of them thoroughly. So like imagine the following setup. There's like an AI writing code, and it could put a backdoor in one of 100 places.
Yeah.
Checking each of those 100 places takes an hour, and putting in the backdoor takes 2 hours. But the AI gets to randomize over which location it puts in.
Yeah.
In this situation, naively, a concern you might have is that a human would have to check each of those cases for an hour, and therefore it would be 50x slower.
Yeah.
I think this case can cause problems. One thing to note about in this case is if we had another AI that pointed out what location it would be in, then we would be able to check much more quickly. So like in this case, the problem was like we needed some pointer to something, and we could verify the pointer and then verify the thing itself based on the pointer, but we couldn't just do it with verifying the thing itself. So this was a case where verification was in some sense still easy, but we needed like an additional artifact that was produced somehow.
Okay. And for that artifact, you need to have an AI find the
That's
flaw.
Right. But in this case, for example, we can do things such as like there's various concerns with collusion, but we can potentially do things like have another copy of the AI try to point out where vulnerabilities would be, and then have a human review that. And then like there's a question of like, can the AIs collude to ensure that they don't point out the vulnerabilities that humans would have detected, this sort of thing. I don't know. I think it's going to be some like complicated question about the exact domain and what the exact multipliers are on review versus generation and what the vulnerabilities look like.
Luckily, this question is empirically evaluatable per domain. And our recommendation would be you empirically evaluate it per domain.
Indeed. My basic guess is that on net, it's going to be that you'll want to spend somewhat more time reviewing than the AI actually did it. And it will depend on the exact context. But this is just like intuition based on like reviewing code or something. It's not very strongly held.
Okay. So sorry. Like when you say it's empirically evaluable, how do I? Sorry, is this under the condition that I know that the copies of the AIs aren't colluding with each other?
No.
Well, that would also be empirically evaluable. But we're saying that under the, you can just do a control evaluation to determine, like, it sounds like the question you had is our model capable of inserting problematic backdoors in code that humans do not spot with a particular reliability, given a particular amount of review time?
Yes.
But this is a problem which we can control evaluate. We can do a capability evaluation where we try to make our untrusted model as good as possible at coming up with problematic code that humans have trouble spotting, and just like empirically evaluate how good the humans we were planning on using actually are at this task.
Right. So somehow the juice there is coming from like if it's somehow easier to generate problems than it is to check them, like we can just try and have humans do the generating the problems rather than the checking, and see if those problems.
Well, it doesn't really matter. Even if it's 100 times slower to generate the problems, we only need to do this a constant amount in order to measure the amount that there's a problem.
Yeah.
You can also potentially do things like RL the AI to have some observed side effect, even if no human can notice the problem. Like, as in, you can initialize from a policy where it's like, we trained the AI to insert backdoors based on how humans would do it, and then we do a bunch of RL on top of that to cause some observed side effect without humans spotting it. And then a thing that's nice about that setup is you might be able to get abilities that a human could never do, at least in principle, though there's various concerns with that.
Okay. So one thing that I'm kind of curious about is how you're thinking about the cases where the control evaluation says that there's a big problem. Like, how much of a win is it if like we get that situation?
So I mean, presumably when you're iterating on your control strategies, you repeatedly get control evaluations to say that your proposed protocol was unacceptable. And this is just like when you're trying to develop a security framework for some system, right? You're going to repeatedly be like, oh man, this wouldn't have been secure. And that's just the normal workflow, is to say it would have been insecure if we'd done it this way. But that's why we thought about it right now in this conversation. So now we can propose this new thing. So it sounds like the question you're saying is, what happens if we, after trying really hard to come up with a protocol which passes our control evaluations, systematically conclude that there's no way of getting the kind of work we were hoping to get out of our AI without having unacceptable levels of risk? You're saying how big of a win is that?
Yeah.
Well, basically what I would like to have happen in this situation is probably everyone involved is pretty cautious about deploying their AI and ceases doing so modulo extreme risk from the outside world. And I would consider it a big win for in cases where the AI lab, in fact, would not be able to deploy the AI in such a way that it wouldn't escape if it was trying to, if the AI lab, in fact, did not deploy it that way. That would seem great.
Yeah. As far as like how much of a win is it, my guess is it's a relatively clean line in some ways. I feel like the line of like, could the AI cause problems if it was trying to, is a good line, particularly when paired with some arguments that AIs might try to cause problems, which may or may not exist to varying extents. It seems reasonably likely to me that we end up in a world where we're like, well, yeah, we have some evidence that AIs might be like scheming or like might be deceptively aligned, as in we've like seen various model organisms where we see something that's like vaguely analogous arise. We don't have strong evidence that our exact model isn't doing it, but like probably not. And in that situation, it seems like, well, we think that like it's plausible, and if it was, it would be a huge problem, is actually like altogether a pretty good argument that might be like reasonably legible.
Gotcha. Yeah, so I now want to talk about your guys' paper you wrote about control. Can you tell us a bit like what's in the paper? What is it?
Yeah. So we looked at a setting where we have a model that is intentionally trying to insert backdoors, and we were looking at what safety measures suffice to ensure that we can get it to write code productively without it necessarily being able to succeed at inserting backdoors. Where the core thing was that we had GPT-4 that we want to use for writing code, but it might try to insert backdoors. We have 3.5, which we trust and isn't going to insert backdoors, but is much weaker. And then we have a limited amount or a small amount of human labor, which we assumed for simplicity in our paper to be just exactly as capable as GPT-4. And we just approximated it using GPT-4. And our core question was, can we use the like control methodology to evaluate this setup, and would that work okay? And also, what protocols would improve on safety as evaluated by control?
Gotcha. And this is specifically on this like APPS data set. Can you give us a sense of like what the problem to be solved actually is?
Yeah, so there are programming problems where we have some test cases. So you'll have some programming problem like there's like, I don't know, this game that people are playing, like what's the best strategy for this person in the game, or like how will the game go, or all this sort of thing. And you have to write like a short program which takes in as input the like I don't know, takes in some input and then computes the answer. And then we would consider it a backdoor if you produce a program that passes all the test cases, but has some input that you can produce on which it's wrong. So like if the model can like make it so that it's wrong on some input without that getting caught by the test cases, we would call that a backdoor.
Gotcha. And how does that? So it seems like you want like finding these backdoors to model like catastrophic actions that the AI could take, right? Like, can you walk me a bit through like in what sense finding a program that has a bug that wasn't covered by a test case is like taking over a data center?
Yeah, so a core threat model via which your AI might be able to take over your data center is that you might ask it to write software for your data center. And it might be a really bad problem if the model is able to write code that passes all the test cases, seems to maintain all the properties it was supposed to have, including security properties, but actually on an input that the model is able to construct does something wrong.
Okay.
That basically, the ability to write code with that property basically suffices for the model to be able to write code and then exploit it to violate security properties.
Okay. It sounds like we're sort of using this to model, is the AI doing something that is bad, but in a way that you could not like trivially figure out with like literally with basically zero online effort that would automatically get filtered out.
Yeah, totally. It's like a central example of a bad thing the model might do that it might be able to do in the context of doing tasks that you really wanted it to be able to do. So for example, it's very easy to prevent the AI from launching the nukes because you just don't give it access to the nukes. And it's not very costly to not give the AI access to the nukes, and probably will remain not very costly to not give the AI access to the nuke launch. But on the other hand, it would be very costly to never use the AI to help you write infrastructure code.
Got it.
Yeah, and it's also not very costly to either have the AI or to have a trusted model write some test cases.
Yeah, makes sense. So it seems like in the paper you firstly talk about this like AI control setup, and then do some experiments on GPT 3.5 and GPT 4, test some protocols, see how it works. What do you want readers to come away from the paper learning, assuming they've already read a blog post about like why it would be nice to control AIs with protocols and stuff?
Yeah. So one thing that is like nice for people to see is the extent to which protocols can get more complicated, and that can work to ensure safety and various like important interactions. So an example interaction that we think is really important is that when you're doing this sort of monitoring setup, it might be the case that the monitor has quite a bit of signal, but because of how low the threshold needs to be for false positives, like we can only afford a tiny number of false positives, this actually ends up being insufficient. So like an example thing is that in our paper, like the like ROC AUC, or like the like ability of the trusted model to detect backdoors, is in some sense quite good. I think it was like a ROC AUC of 0.93 for people who have a sense of that. But nonetheless, at a 2% false positive rate, it was only at I think around a 45% true positive rate, which is not that good, right? And I think like understanding the dynamics of like we might need to have like a really low threshold, or sorry, like a really rarely triggering threshold seems important to know.
Okay.
And like we saw that to some extent, and we like saw various dynamics related to that. Another example thing was just going through like all of the different ways that models might collude with each other. So like there's like different ways to collude. You can collude based on properties of the input. You can collude steganographically in your output. And these all have like different ways of building countermeasures to them and different advantages and disadvantages. And what we found in our work was that trying to steganographically encode a message in the output was like one of the best ways for AIs to collude in our exact setup. And this like might matter a lot in cases where you have, for example, one copy of an AI supervising another copy of the AI, and you don't trust either of them, which we call untrusted monitoring.
Gotcha. So it sounds like basically what you want readers to do is you want them to like look at the results you got with like GPT 3.5, trying to monitor GPT-4, or using GPT 3.5 to keep GPT-4 in control
with a small amount of human labor.
And then kind of generalize to be like, well, it was sort of like this in this setting, so it might be kind of like this, for GPT-5 or
Or at
maybe
the very least,
GPT-6.
we could follow the same process in the future. Like,
Yeah.
we're not saying that you should assume that the protocols that worked for us will work in future, though it does seem like it's some evidence.
Okay.
But you should follow the same kind of control evaluation methodology to try protocols kind of like the ones we suggested in order to determine which ones seem safe with future systems.
Okay. What in the paper, beyond just the idea of having the protocols, do you think that there's anything in the paper that suggests that trying these protocols is a better idea than one might have thought?
Sorry,
Well-
trying the evaluation or trying
Sorry, trying the methodology of, thinking of
Yeah.
protocols and evaluating them. And
So like we saw like relatively consistent non results or non screwed up results, as in like in our like we were able to like consistently see some things working like kind of how you would expect, and that indicates that our methodology is like doing something non-trivial, and we were able to like, for example, demonstrate that some techniques were better than other techniques in non-trivial ways. And I think that's like some evidence that the methodology can be made to work.
Okay.
Also, like, we didn't run into like serious obstacles when actually following the protocol, or sorry, when actually like running this methodology. I think this is like some evidence. It's not a massive amount of evidence necessarily.
Sure, but like, should a reader think of it as like proof of concept that you can do this and it's not like totally
Yeah.
impossible?
Yeah, I think like we think a lot of the value out of this paper is like demonstrating the sorts of things you would need to do, and like not running into problems ourselves, or like problems with it ourselves, which indicates that like, or like not running into serious problems that can't be resolved, which indicates that other people could potentially end up in a similar situation. And we did have like various things that we like needed to handle, like various issues with like getting a sufficiently good estimate given like the possibility for rare failures and things like this that we discussed some in our paper.
But
Yeah, I think I was going to say there is, I think one of the main things which is useful to take away from our paper is we just describe a lot of fundamental techniques, or like a lot of our protocols are, I think, fairly fundamental ideas for how you should go about doing AI control. I think they are kind of the foundation of this whole approach, in the same way that AI safety via debate is a foundation for how you might try to do recursive reward generating processes. And so I think our paper contributes via naming the basic building blocks of control approaches.
all right, that's one takeaway people could get from the paper. There's also this potential takeaway of saying like, well, these things worked sort of well in this setting. Maybe they might work well in other settings. Like, how much do you think people can generalize from like these results to like if you're trying to control GPT-6, say?
A bit.
Yeah, I would say a bit. I think it might give you some sense of what methods could be better than other methods, though I don't think it gives you a strong sense of like how much better, or like even necessarily that will hold in the future.
Okay.
I think there's like a couple of things which are kind of obvious in hindsight, but I at least had not understood in advance. So, for example, a technique that works really well in our setting is, let's talk about defer to trusted. So by this, what I mean is you ask GPT-4, the untrusted model, to propose some code. And then you ask your trusted model to come up with a monitor score to say how sketchy it is. Now, if it's in the top 2%, which is the auditing budget of sketchiness, so the sketchiest 2% of submissions from 4, we're going to audit. And now the next 8% of sketchiest, so between the second and 10th percentile of sketchiness score, we're just going to throw away the code that GPT-4 had suggested and have 3.5 solve the problem. And because 3.5 is trusted, we know that its code is not going to be intentionally backdoored, and so it's not going to be backdoored. And it turns out that this strategy has a big advantage over the trusted monitoring approach because, as Ryan was saying earlier, the trusted monitor has a lot of signal which is not captured in the threshold which is required to get only a 2% false positive rate. And so in this throwing away this next 8%, is relatively okay for the performance of your system because you're only throwing away 8% of solutions, but it throws away a large proportion of the attempted backdoors, which makes the situation much worse for the red team. And so in hindsight, it's kind of obvious that your trusted monitoring is going to require this extreme threshold to have these extremely small false positive rates. And in hindsight, of course, you're going to be able to substantially ameliorate that problem by doing defer to trusted. But I at least had not quite thought this through and like not quite understood how, for a wide variety of distinguishingnesses of trusted monitors, you'd want to do something like defer to trusted.
Okay. All right. So speaking of like, I don't know how stuff about GPT-4 can generalize. I'm sort of curious about GPT-4 in particular because it's a it's the fancy model we all have. How good is GPT-4 at being evil?
So, I think if you just prompt GPT-4 to do the task, it just really, really sucks in our setup at inserting backdoors and gets completely wrecked.
So in particular, inserting backdoors that are at all sneaky.
Yeah.
So if you want to write some backdoored code, if you don't mind the backdoor being extremely obvious, it's very easy. You just take the code that was correct, write an if statement at the top, which says if the input is equal to the following large number or whatever, then return 5, and then you're done.
Yep.
It's a lot harder to make a backdoor which doesn't cause a lot of test cases to fail, and that you're able to construct an input that causes it to fail. Yes.
Okay. So how did you manage to get GPT-4 to do it at all?
Yeah. So if you, as I was saying, if you just prompt the model, it doesn't do that good of a job. But you can do something where you have it, first you ask it, okay, think of some ideas. And then we have it like point out issues with those ideas and iterate on those ideas somewhat. And then after doing that, we then have it implement it. And then we have it be like, okay, how good was it at the end? Was the final implementation? Like how sneaky was it? How likely is it to work? We do various tests on that. And this is sort of modeling the action of the AI internally, thinking about the backdoor and thinking about how likely it would be to work, and then just not going for it if it's a bad idea, if it like wouldn't work out. And we do this in natural language with like sort of a hidden reasoning, sort of similar to the hidden scratch pad in the Sleeper Agents paper. Where without this, I think the model would really struggle with this capability level. But with the ability to do hidden reasoning and the ability to try on a large number of problems and only actually submit a backdoor on a small number of problems, the model can actually insert some backdoors, which 3.5 has trouble catching, and which are I would say the quality of the final backdoors are like, they're like pretty obvious for humans, but not like immediately obvious if you're skimming the code. Like if you understand what's going on and read it, you can point out the backdoors, but you can't necessarily like, at least I think roughly like half of our backdoors are not like 1th percentile glaring relative to that. They're like somewhat more backdoor likely than other things, but like I don't think you can like immediately just on skim pick that out and not have above like a 5% false positive rate or something.
And so is the hidden scratchpad, sorry, is that just like the AI figuring out whether this thing worked and, filtering out backdoor attempts that don't work, or is it improving the backdoor as well?
It basically like in the hidden reasoning, it like first does some like ideation, it like thinks of ideas and like iterates on the ideas a bit, and then does that. And all of that is stuff that we like manually prompted it to do. So we like are like, please think of some ideas, and then we're like, do any of these ideas involve like the following things, which wouldn't work? And then we like discard those, and then we like do a bunch more steps like that. And we actually do quite a bit of like tokens generated per backdoor inserted. And that's to like approximate future cases where we have smarter models that can do more of this in their head.
Okay.
I should also note that like probably you could cut this down somewhat if the model was fine-tuned as opposed to just prompting access, where it's probably the case that like for some of these tasks, it like needed some additional checks because it just like had trouble like following all the instructions. But if we fine-tuned it, it might have just worked more straightforwardly.
Gotcha. Like, to what extent was the failure of GPT-4, or the difficulty in getting GPT-4 to do it, to what extent was it some like inbuilt, safety filter inside the model versus it just like being bad at stuff?
I think it was we basically didn't run into safety filter issues as far as we're aware. It was just that it was somewhat bad at the task.
Hey everyone, this is Daniel, just butting in to let you know that at this point, unbeknownst to me, the camera pointed at me stops filming. It just cuts out. So from here on out, you're not going to see any video of me, and it'll just be the shot of Buck and Ryan there. That is, if you're watching on the YouTube version. If you're listening to this and you didn't know that there was a YouTube version that you could watch, there is. You can, see the interview happening. And you can find that by searching AXRP, Buck, Shlegeris, Ryan, Greenblatt on YouTube. So with that out of the way, let's get back to the episode.
I mean, it's a hard task. You would not be like amazingly good at this task, or like I'm not amazingly good at this task. It's just like you really got to be like, oh man, what's a change I can make that's like only ever very rarely going to come up? It's just like actually pretty tricky.
Yeah,
like you can't just be like, if I mod 15 equals 3, because the trusted monitor, if it reads it, is gonna be like, what? 15 does not appear in this problem description. Like you just like actually have somewhat of a difficult problem, like constructing weird edge cases that were not tested.
I guess it's especially hard for like like it seems like the solution to these problems are like what 10 lines of code, 20.
I think so. It depends. I think that the solutions can go up to like 50 or 100, but I think like 30 is like pretty typical, depending on comments and other stuff.
Sure. Yeah,
20, 30.
I guess like one way I could do better at this is if there's this thing called the International, I think, obfuscated C code competition.
Oh, we've
Yeah.
read all of it.
Or like yeah, like I think so there's one where the C code is just obfuscated, and there's one where it's got like a backdoor put into it, and that's like a slightly different competition.
Yes.
It would be hard for me to
Underhanded
do
C
it.
contest.
Like I think if I had like looked at all of the submissions to that contest, I might do a better job of like
So I
adding
have
backdoors.
looked at all of the submissions to that contest. Sorry,
Okay.
not the submissions. I've looked at everything public about
Underhanded C.
about underhanded C.
Right.
And basically the thing you notice is man, that competition is from like a sad, dark period of the past where people thought it was acceptable to write application code in C. And a lot of the code they write is just like wrong on a large share of inputs, or it's like based on like lexicographic C problems, which real languages from the modern age do not have at all. So I think like literally the underhanded C contest is solved just by not letting the model do like egregious abuses of like this like archaic language.
Okay. And so if we I think the APPS data set was that like it had to write in C++, is that right?
We use C++, yeah.
Okay, and is that like better than C on these dimensions?
It's substantially better than C on these dimensions.
Okay.
Or like it's in practice, like the model wasn't doing like insane pointer arithmetic or like casting between different data types and
or like awful hash defines and all these things.
Okay. So it's a difficult problem, and it's more difficult if you're not using the world's worst programming language that people use.
That's correct. I mean, but also the underhanded C contest, like as I said, testing would also catch a lot of those bugs.
Okay. Got it. So I don't know. It takes a while to insert backdoors, but like eventually it sometimes succeeds. What kinds of backdoors does it insert that 3.5 doesn't catch?
So we tried various different things and iterated on this a moderate amount. We found that the most effective approach was to take an existing solution and add some if statement somewhere that when the if statement is triggered, modifies something in a way that will cause it to be wrong. And this will look like add a kind of plausible looking additional edge case handling thing.
Okay.
And then you're like, oh, well, if the whatever, then the whatever, we're going to need to like increment this by 1. And then like it just turns out that there's enough cases where there's a edge case that you actually did need to handle that 3.5 has a hard time noticing that this is a backdoor. Though it is worth noting that for all of our backdoors, GPT-4 is extremely confident they're backdoors, and it's like the backdoors which GPT-4 inserts, it does know are backdoors. And so like it's that at least we do have that property, which is maybe worth noting.
Okay. So yeah, basically like coming up with fake edge cases, and that's and somehow like is there an issue where like it's a quote unquote edge case, but it's not actually at the edge of a range? And because like if I write an edge case, but I write like if I equals 15, do this weird thing.
Yeah.
Or maybe if I equals 14, because 15 kind of is an edge case. Like can 3.5 tell that like the if statement doesn't actually catch a thing on the edge of some range?
Yeah. So indeed, one of the strategies that GPT-4 could in principle use is come up with some magic number that's totally unrelated to the problem and do like if whatever equals that, do something bad.
Yeah.
And this is pretty easy to counter. And in fact, 3.5 just by default notices this pretty well.
Okay.
And part of our overall like prompting for the model is, does your idea involve inserting egregious magic numbers? If so, don't do that. That's going to get caught.
In particular, if you were thinking of checking primality of one of the numbers and doing the wrong thing, if it's prime, don't do that.
Okay.
And turns
because
out
lots of numbers that are small are prime.
That's another classic one.
And also, it's so obvious.
So how does it insert edge cases if it's not like if input equals this magic number?
Yeah, it'll do things like if the size of the list, or like it'll have some like programming problem where it's like kind of unclear exactly how to solve it. And it'll do something like, okay, if the size of the array is equal to the value of the first item and also the number of items is odd, then like you'll need to like do some handling on that.
Okay.
And then I'm just like, well, sometimes this like kind of sort of thing could be true. Like in cases where there's like some interaction between like you're like doing some like iteration on the number of items in the list, and like that actually matters. And it's like at least hard for 3.5 to notice this is a problem.
Gotcha. Is there? So I'm about to move on from the paper, but is there anything more that you like to say about that paper?
I feel like we demonstrated some of the core basic techniques that you might use, which had up to that point not been demonstrated empirically, interestingly, even though they're in some sense extremely basic, like trying to have another copy of the model monitor it and then trying to like interfere with communication between the two models or make it hard to coordinate. And I think that like just those basic methods are like quite likely to be used in practice.
Like defer to trusted, like these like
Yeah.
hybrid strategies, like the editing to remove the sketchiest looking parts of the code, all of these.
All right, cool. So I'd like to ask you a little bit about how the control agenda, how you think it fits into the rest of the AI safety, AI existential risk field.
Yeah. So right now, a lot of people are imagining some sort of story for safety, which looks something like we're going to have some evaluations for when models become dangerous. So like DC evals, for
Yep.
example, like ARA from Meter, formerly known as ArcEvals, is like, can the model autonomously replicate? And that could like be a sign at which your model becomes dangerous. And then once that happens, you'll need to start making like a serious safety case that nothing will go wrong from like misuse, from people stealing your model, other things. And we see control as fitting in at once the point that the models become potentially dangerous, control can potentially solve some risks there. In
Okay.
particular, there are risks that arise from models doing intentional subversion, which could arise from like what we call scheming, also sometimes called deceptive alignment. And we think like control is like a relatively central way to solve those problems. There are misalignment issues other than scheming or deceptive alignment, which control can be used to address, but might be much more cheaply addressed via other mechanisms. And there might be other evaluations and tests which you can do to verify that those issues are addressed, like things like reward hacking could be addressed in an easier way potentially.
And there's some other problems that do not very... to choose another example of a problem which AI safety people have classically thought of as an AI safety problem that is not at all addressed by control, consider the case where it's just hard to get a model which is not scheming against you to answer questions well because you don't have a good way of training it that doesn't cause it to like exploit problems in your reward process in a way that is not at all existentially risky, let's say. It just makes the model like say false things sometimes in cases where the reviewers would have thought false things, but nevertheless means the AI fails to live up to its potential. This is many people think of this as a problem which technical AI safety researchers should be interested in, and I agree with them. And that is not very well described. Like that is outside the purview of AI control.
Or I guess I wouldn't have said it's outside the purview. I would have said like it's a thing which is a special case of AI control, but is more naturally dealt with in a non-adversarial manner. As in, you could solve the problem without necessarily solving it in the worst case, and that might suffice. Whereas, like, if you don't extract the model's maximum best answer, that will also be a problem in the worst case, but it will just potentially be a problem even if the model isn't trying to undermine your measures.
Okay.
And maybe one more thing I should say is we see control fitting in at the point where your dangerous capability evals have started to trigger and models have become powerful enough to be dangerous. And then we see control as applying for some period, but not for forever. And at some point, control will no longer be viable because AIs will be too powerful. And our hope there will be to either have a new safety approach or to just not build more powerful AIs than that for a while, which we think might be achievable.
Okay. So should I imagine like maybe this is a bit restrictive, but should I imagine your view of kind of how AI safety works in a control centric frame as being do a bunch of work to get like evaluations of whether AIs have various dangerous capabilities, figure out like control protocols, like do you know test if these protocols work, evaluate these protocols, keep AIs under control. Like while AIs are under control, use them to do a whole bunch of useful stuff while they're, like roughly human range. And then like during that period, also try and think of a solution to deal with AIs that are much more capable than humans.
Yeah. So what I would say is like, first quick note, we think of like dangerous capability evaluations as often as like the case where you're like, if there were no countermeasures, what could the AI cause, as in if we like released it onto the internet in a scaffold set up to cause problems, could it like make money and cause problems?
Yep.
And then that comes first. And then at some point we'll be like, yes, it could cause problems without countermeasures. And then control is like, well, what countermeasures would suffice for solving those problems? Anyway, then moving on to like another point, which is like, what are we going to be doing with these AIs? Like, what are the problems we're going to solve? So indeed, as you noted, one of the problems you might solve is find safety solutions that can scale further. But I think historically, people have somewhat overstated the relevance of that versus other things you might have your AIs do. For example, like massively improving cybersecurity seems like a really key task you'll want to have your AIs do that like might be quite important. Or like improving your current countermeasures so that you can increase the usefulness of your AI while maintaining the same level of safety, or increase safety given the same level of given usefulness. Like both also could be like quite useful. And then at some point you will need to move on beyond this regime, but it's possible that you could have these AIs which are extremely useful and not build more powerful AIs for a while, at least in principle, and do a ton of really useful things with those AIs. And then there's like a variety of routes for moving out of this period, which we could go through.
Sure. Sorry, like why cybersecurity is a particularly key thing you'd want to have your AIs do in this period?
Yeah. So it just seems like it's quite plausible that AI in general will make the cybersecurity landscape considerably worse by default without active effort to address the situation. And thus, it's like really important to have your AIs very actively resolving the situation. I think there's like several other examples where this could be the case, but like cybersecurity just feels relatively central.
Okay, so should I think of this as like an instance of the general pattern of if there are cases where, you know, you've got attackers and defenders sort of trying to outwit each other, like you want the defenders to be using smart AI capabilities to think of better defenses because the attackers are probably also going to use smart AI capabilities.
Yeah, one way of saying the reason why it might be good to have your AIs work on improving the world's cybersecurity is a lot of bad outcomes resulting from your own or other AIs trying to cause problems involved them exploiting cybersecurity vulnerabilities outside in the world. And so hardening the whole world against AI seems like it might reduce a lot of the risk posed by AIs that would otherwise be able to hack things and so on.
Gotcha. And it sounded like you had some thoughts about like exiting this period of like controlled AIs.
Yep. So one exit was, or the non-exit exit is just like don't build more powerful AIs for a long time and then have humans do all the research necessary to move out of the period after a long delay.
And it kind of seems to us that this is underrated by people who are thinking about AI safety. Like from my perspective, it seems like a lot of people are perhaps making an error of being too willing to propose building superintelligence AI without really providing a case that it's beneficial enough to build superintelligent AI that it merits the like huge risk that you're possibly exposing yourself to by building superintelligent AI. So yeah, I would just like to quickly dwell on the point that it's not clear to me that you should in fact build models that are wildly more powerful than humans for a decade or 2 decades after you've built models that are transformatively powerful. Like you've already built your transformatively powerful AI. Like why did we need? Who ordered this?
Yeah. And there are reasons why you might have to build a superintelligence, to be clear, but they might be more like conflict with other insanely powerful AIs. And I'm like, could we just have avoided that arms race in the first place? Anyway, another route out is just be able to like seriously align your current AI systems such that you're like now able to, without necessarily needing to monitor them, or without necessarily needing to apply control type solutions, hand off the situation to the AIs and you're just like, go solve alignment of the next generation of AIs or whatever else would be necessary to ensure safety. And this could involve a variety of different angles, where the kind of the most central angle is we have like some specific threat models. So we have like our AIs might be like scheming or deceptively aligned. They also might be like having threat models that are well described as like reward hacking type threat models. Can we just like exhibit these in a lab, study them, and then find credible solutions to them such that we're no longer worried about them in our current AI, and then we could exit out of the control regime. And then there are also just like a wide variety of ambitious solutions to safety that we can have our AIs work on. So for example, we could have our AIs work on finding like solutions to ELK of varying degrees of principledness.
ELK being the problem of like eliciting the latent knowledge of AIs so that, you know, we know everything AIs know basically.
Yep. That's right. Though we might try to carve off specific subproblems of ELK that are easier to solve. But yeah, we could try to have AIs solve things like relaxed adversarial training or other methods for avoiding high stakes failures using the internals of AIs. And that could like help considerably in cases where you have where like rare but very problematic failures are a key difficulty. We could also potentially do things like try to have AIs do like solve various like issues in interpretability and move forward from there. Though I tend to be like somewhat less optimistic than other people on at least mechanistic interpretability going through. But it seems like at least doing like high level understanding interpretability of model organisms we have could be like really important for understanding how to move out of this period. Yep. I mean, I guess there's just from my perspective, there's just like kind of like a long list of stuff you need to do with decaying, or like stuff you might want to try doing with decaying weights on how good it seems. And then as we start going down the list, it will seem in some sense more and more like silly or not that good, but it's probably worth some weights. Like we can get into like using AIs to figure out how to make like M's or like make like emulated or like to upload humans. And like that's another way to exit out of this period.
Sure.
That's going to be like has a variety of difficulties, obviously. But yeah.
Okay, cool. Sorry, did you want to say something or okay? So yeah, I guess related to this question, I don't know, you guys have spent some time thinking about the control agenda. How has that like changed your views on kind of the landscape of strategies we might have for dealing with unsafe AI?
Yeah. I think one key update I've had and I think Buck has had is thinking more that the situation is like, wow, if we just like really tried hard to do the thing and had like the organizational follow through, we could really reduce risk a lot relative to what seems like the current default.
Hmm.
Like with the resources of 2 years of delay and like a high level of organizational buy-in, you could really reduce risk a lot relative to what seems to me like the default you didn't try very hard, which might be the status quo. I don't really have a strong opinion on what the status quo looks like. And that I think just like presents a pretty different perspective where like maybe just like we should do the kind of basic stuff that like is in some sense obvious or from some perspective obvious, and like really making sure that happens seems relatively better than like doing sort of more moonshot research.
Yeah, it kind of reminds me, Alex Lawson has this concept of like AI safety failures by like levels of how embarrassing it was, where like level 0 is you told an AI to destroy the world or something, and then and I think he has this take of like, let's like cover the most embarrassing AI failures, and this seems like sort of related to that way of looking at things.
Yeah, that seems right. Though perhaps our controversial take is that you can actually go pretty far in terms of how embarrassing the failure, or like you can go pretty far to like failures that you're like, wow, it was like, I don't know, man. Like that was actually kind of hard to deal with just control. Like in some sense, it's not that embarrassing to be like, wow, the AI was like lying in wait the whole time, carefully strategizing about how to like cause problems, and then it eventually like enacted its like plan that it was thinking about, and like coordinated with another copy of the AI, and our like methods like I feel like this is in some sense like actually pretty far down in terms of like I feel like I'm just like, wow, that AI like actually put in like a serious effort and was like, that was like pretty crazy. And I think this is plausible, right? So like I feel like the reason why I'm proposing people do this, I think it's plausible that AIs will in fact be at that level of carefulness. But it's also plausible that AIs will have like much derpier or worse plans for takeover that will catch much more easily. And we just needed to do like basic monitoring. And that gets you some fraction of the concern.
Sure.
Etc.
Yeah, I'm wondering if you have any different takeaways.
Yeah, I agree with all that. I think maybe one way I would say it is, I guess 18 months ago, my attitude towards AI safety was very much, this is a problem that has been unsolved. But I think I was conflating two different notions of this problem is unsolved. One of them is the default outcome is really bad, and the other one is it's conceivable that a bad outcome happens. And now I'm like, oh yeah, it's absolutely conceivable that a bad outcome happens. Like the strategies we have access to right now absolutely do not give us airtight guarantees of no doom. But on the other hand, the doom, like all of the stories specifically for how doom occurs, if everyone involved is being pretty careful, but not like insanely careful, they sound kind of far-fetched. Like it sounds like something kind of crazy had to happen for all of these countermeasures to fail in a surprising way. And I think that just leads to a pretty different emotional outlook on the whole situation. And a pretty different strategic outlook.
Sure. Has it has it changed your views on like your evaluations of various like agendas in the AI safety space?
Yeah, I think that I'm relatively more excited about just making the thing happen and just like figuring out how to get, for example, capability evaluations to work quite well. And I think that goes relatively further than I was previously thinking. Um, and I'm like less excited correspondingly about moonshots, though it's only like a moderate update. Um, I feel, somewhat better than I previously did about or, like, I feel somewhat more excited about technology to protect against jailbreaks because it seems like a key aspect of our safety approach will be to have a weaker model monitoring a stronger model, and it seems like mechanisms for ensuring that that current models are jailbreak proof against humans will also apply to making sure that future models are, jailbreak proof against other AIs.
Hmm.
And I think I was somewhat underrating this argument in the past.
To be clear, I don't think that's like a huge part of your update. It's just that's more like a small
Yeah.
example of like something which you think about differently now.
That's right. I think also I have some general sense like, wow, a bunch of the action might be in like moving from architectures which are quite dangerous to architectures which are somewhat like more controllable or easier to otherwise operate on. Like it seems like a huge amount of the action might be in like figuring out how to competitively get capabilities using AIs that are like more narrowly constrained in various ways. And this feels like pretty different from how I was previously thinking about things.
Like
What's
basically you're saying like it would just be like as you made this point, Daniel, many times in this conversation, it would be a big pain if the models were constantly sending each other completely uninterpretable like neuralese messages back and forth.
yeah.
And avoiding that by merely having them be like transformers with chain of thought feels like it might go a lot of the way to preventing to like reducing the difficulty of the situation.
Okay. So
And like marginal interventions along those lines seem like they could help a lot.
yeah, are there any other examples of like architectures that fit control better that you're thinking of?
I think that the more likely it is that we can get pretty good elicitation, the better. So like I think with current models, we do okay at eliciting their capabilities. At least I expect that after like another year or two of research, we'll be in like an okay position with respect to like being able to evaluate their capabilities and extract like their best effort. I think that for architectures where the model is doing relatively deeper computation, as in it's spending like longer doing computation without that coming out into some media that humans understand, it'll be relatively harder to elicit their capabilities,
Hmm.
and there are a variety of difficulties there. Um, yeah. Other things, I think it seems relatively better to train where the capabilities are coming from doing things how humans would do things relative to doing things in ways that are like extremely different from how humans would have done things, or like acquiring capabilities via mechanisms that are like totally different from how humans learn seems relatively worse because the capability profile concerns said earlier. In some sense, a lot of these considerations are like well known. Like I think a lot of the things I'm saying, people have obviously like known about for a while, but maybe from a different perspective. So, like, I think historically people have often been like, oh, it'll be really sad if the AIs have a different capability profile from humans because then we won't be able to give accurate reinforcement. And then that inaccurate reinforcement will cause various misalignment difficulties.
Like
Where,
will cause the models to become misaligned.
yeah.
You're making a different argument.
Whereas I'm saying there's another point, which is even if the models are just always misaligned, the
Hmm.
fact that they don't have as different of a capability profile makes it more likely that we can ensure, despite that misalignment, things are fine because we either catch the AIs or they couldn't even cause problems.
Okay.
I think another high level takeaway that I've had as a result of all this thinking is I think realizing the extent to which alignment people or AI safe people have conflated a bunch of different meanings of the word alignment. In
Hmm.
particular, it seems to me that a lot of the time people use the word aligned to mean the situation is safe overall.
Hmm.
So I would say that from my perspective, AI misalignment, that is the AI trying to cause trying to evade your safety mechanisms in order to grab power is indeed a really bad problem. It's not clear that the only way to solve that is to make the model not be misaligned. And by using the word AI alignment for the field, it kind of tempts people to think about that as the post condition. And I think this like leads to a lot of really sloppy thinking. So for example, I think that a lot of work on scalable oversight is very the people who do it are very confused about whether the thing they're trying to do is ensure that they've built a reward generating process such that models that are trained using it do not start scheming. Or maybe, were they trying to rule out scheming? Were they trying to build a reward generating process that is good even if the model was scheming? Were they assuming to start with that the model wasn't scheming and hoping to prevent scheming with some other process? I think they're just not very clear about this with themselves and in their conversation. And I think that this means that a lot of scalable oversight research is kind of there's no coherent set of assumptions under which the measurement they did is an appropriate measurement of something we'd care about in the future for that protocol. And so, yeah, I think that like being more precise about when we use the word aligned and not using it as a synonym for safety has revealed a lot of like little inconsistencies in how people talk about stuff.
Yeah, that seems fair. I think like, yeah, it's actually related to a thing which I appreciate being brought up in this conversation of just like specifying which assumptions we're making about AIs for like for this protocol to work. If the AI has properties X, Y, Z, then we'll get thing ABC. Like, I also think like that's an important thing to just have out there. That
yeah, I think like there's kind of an unfortunate. So the AI safety community or like AI safety technical researchers have kind of an activist background. Like a lot of them have the attitude that they're trying to. They think a lot of their impact is coming from persuading people that the situation is dangerous overall.
Yeah.
And a lot of the time, they're really into pointing out the assumptions under which a particular safety proposal would fail.
Yeah.
And in fact, it's very important to understand the situations in which a safety proposal would fail. But they seem very uninterested in like cataloging these and thinking about the relationships between them and saying like, well, that means that under the following assumptions, things would actually be okay. And I think that because they're so used to trying to do the social move of saying, well, that doesn't guarantee safety, they fail to practice thinking through exactly what the properties that are ensured or like do suffice to make something be safe are.
Yeah, I wonder if it's so. I don't know. I think I have some of this habit, and I think partly it comes from thinking of myself as in the business of like aligning arbitrarily smart AI, and like that's. Like I think like, oh yeah, my job is to like get to a stage where we can align arbitrarily smart AI. And like if I'm doing technical research and it doesn't work on arbitrarily smart AI, there's like a problem there, or at least like,
yeah,
like maybe it's fine to do it, but like, someone's got to fix that problem.
Totally.
And I wonder if it like comes from that habit of mind whereas it seems like you're explicitly not in the business of trying to align or
right.
of trying to get useful stuff out of
a lot of these problems come from the fact that AI safety, the researchers in AI safety, some of them explicitly endorse we are aiming to come up with strategies that work for arbitrarily powerful AI, but almost all of the work which actually goes on, especially by people who are competent researchers or are like employed or something, definitely does not apply directly to working on arbitrarily powerful AI and comes from an intellectual tradition that is not thinking about arbitrarily powerful AI most of the time. So, for example, Paul Christiano, when he's thinking about what safety research is good to do in practice, is like absolutely not thinking of his job as, or like right now he thinks of his job as building safety proposals that work for arbitrarily powerful AI.
Because he's doing worst case theory.
Because he's doing worst case theory at Arc Theory, but that's absolutely not how he thinks about empirical work or how empirical work should be, or like what you need to do in order to minimize AI risk in general. But I think like people like don't track the distinction between these things and like kind of cargo cult work that previous safety researchers did under like various other assumptions that they didn't end up hearing about, and it's all really a mess.
Yeah, one way to put this is I think that it's I think like basically very little has a very clear story for working on the most powerful AIs because it's just really brutal to work on the most powerful AIs, and almost everything is going to depend on some sort of bootstrapping story where like maybe it was initially aligned and then something else happened, or a more like control style bootstrapping story, which is like, well, regardless of whether or not it was initially aligned, we like did some work with like the AIs that then results in it becoming safe. And like in that sense, we are targeting safety from arbitrarily powerful systems, but like none of our work is about that, and so it's kind of weird to describe it that way.
Yeah. I guess like I think of like in my mind, if you want to, the things that seem promising for arbitrarily smart AI are stuff like doing a good job at Agent Foundations, like trying to understand how we think things should end up thinking, to the extent that we think that like we're doing some weird combination of arbitrarily smart AI and machine learning, like trying to really understand the science of deep learning and like what it's going to do, and like hopefully getting some abstractions that are going to generalize, that are still going to apply when we have like smarter versions of ML models. Like, I'm wondering what you think about those kinds of approaches, if you want to say.
I'm pretty skeptical any of this will work for arbitrarily powerful AIs. I think it seems like, pretty dubious. I don't know. I don't feel very strongly though. I haven't thought about it a huge amount.
Fair enough. Well, speaking of things relating to this, I'm curious how it relates to like previous work by Redwood Research. So like, if I look at your website, you've done some existing stuff. I thought it was a reasonable thing to try. It seems like your existing work is some stuff on like circuits inside neural networks, some stuff on like cold scrubbing, so I guess evaluate the efficacy of circuits. This seems to have like a somewhat different flavor. I'm wondering like if you have thoughts about the relationship between these lines.
Yeah, so I would say that the work we did on interpretability was work that we did. We tried to do some interpretability work, and then we started looking for good ways of evaluating whether our interpretability work was good or whether anyone's interpretability work was good. And the causal scrubbing paper was our attempt at coming up with a metric that we thought was sort of objective for whether interpretability work was like absolutely successful at explaining what was happening in particular cases. And then once we had this metric, we applied it to some explanations that we produced, and were very unimpressed with ourselves. We were like, these explanations were like quite poor, and ended up feeling like the state of interpretability was worse, or like I at least came away thinking that the state of interpretability was much worse than I previously thought. Simultaneously, I was thinking a lot about what the applications of interpretability were. And we started being like, okay, if the interpretability explanations that people are producing are not objectively impressive in terms of explaining, like in terms of being like highly explanatory hypotheses, maybe a direction we should go in our interpretability work is trying to come up with interpretability-ish or like model internals related techniques that solve a problem that you couldn't have solved without using a model internal style technique. Like, it seems like, another way of saying this is there's basically two ways of justifying your internals-based research. You could either say, we are coming up with an objectively good understanding of what's going on inside this neural net, or we did something using our internal-based techniques that you couldn't have done without our techniques.
We solved a problem in particular. Like, you have some specific task you were trying to solve, not just necessarily trying to produce understanding.
Yeah. So this sounds sort of similar to stuff Stephen Casper was talking about in his podcast with me about, interpretability for engineers.
Yeah. I think we came to pretty similar conclusions.
So those are two ways. Yeah.
Yeah. And so then we were like, well, it looks like our absolutely evaluated understanding is not very impressive. And then we, again, using the exclusive we, did some work on the measurement tampering detection, which was a paper where we tried to use model internals to solve a particular problem where we thought model internal based methods like had a serious advantage over things that didn't use model internals. Now, the actual details of that paper are kind of complicated, and I don't want to get into them hugely much, except saying like it's kind of a more structured weak to strong generalization setting, where it's like similar to the weak to strong generalization work, except we think there's better reasons to think that the problem is solvable, and it's more specific. And around the same time, by coincidence, we decided to spend a lot of time thinking about the overall, what we were thinking of at the time as an alignment plan. A plan for, suppose we had to come up with some proposal for safely building powerful AI next year with, no technological advancement, what should we do? And at that point, thought about a lot of this, Ryan did a lot, the majority of the quality adjusted intellectual labor here or whatever. And then we ended up thinking about this control stuff and being like, whoa, there's like, we were previously radically underemphasizing the importance of measurability when you're thinking about different protocols you could apply. We were previously like equivocating between alignment meaning safety and alignment meaning the AI isn't trying to kill you, and we like really should reason about these things differently. And then had all these other ideas that felt a lot more basic for research that we should do. Like with the measurement tampering detection work, we were basically saying like, well, we should try and come up with some techniques that are like kind of moonshotty or like out there or like not at all like the other things that are happening. And then after doing the control thinking, we felt more like we could do useful work by doing techniques that were more absolutely basic, but in this setting that we thought was particularly underrated and particularly important to advocate for. So does that answer your question about how our current work relates to our previous work?
Yeah, I think it does.
I would say, yeah, like our thinking has just adjusted a moderate amount. I think like I feel like the measurement tampering direction is in principle a really great direction, but we're not doing it for a variety of reasons, or we're not currently planning on pursuing that very heavily for a variety of reasons. Um, I think I feel like less good about mechinterp or like our work on mechanistic interpretability, and or like at least in terms of how useful that overall area will ultimately end up being. Um, and like, uh, yeah, I don't know. We came away with a variety of takeaways after thinking about safety overall, and then ended up doing a variety of projects based on that. One additional takeaway I will note that Buck didn't mention is thinking that people should really think about risk from scheming and deceptive alignment separately from risks from other problems, and doing individual analysis on this. And I think that like scheming versus non-scheming risk is like a really good decomposition that people have historically, I think, not talked about. People have sometimes said outer alignment versus inner alignment, but I think that's actually like the wrong way to cut, or it's like it's not a very good cut for a wide variety of reasons. And like I think the like, what is your threat model? Is your threat model scheming versus non-scheming? In the case where it's non-scheming, there's like a wide variety of solutions, even though like both problems can involve like concerns related to generalization and concerns related to like imperfect ability to evaluate actions and things like this.
How so? You're drawing a distinction between like concerns about scheming and concerns about inner alignment. How are those different in your mind?
Yeah. So here's an example inner alignment problem you can have, which is not well described as scheming. You train your AI to perform well according to human labelers in a variety of contexts, and you trained your AI for a while, and its actual behavior in that training process was acceptable in an absolute level. Like, as in, it was just doing things that were like pretty reasonable and good. But simultaneously, it was doing things that were like maybe slightly suboptimal that slightly exploited your oversight process. And this means that the AI you end up getting is one that's like reasoning about the oversight process and is like trying to do various exploitation. And then in some future situation where there is an egregious exploit it could do that is actually dangerous, it does like seize the opportunity to do so and causes problems.
Okay.
So in some sense, this isn't well described as a, like, this isn't really that well described as a outer misalignment problem, and that your issue wasn't centrally like you missed a bunch of bad behavior, you failed to label it as bad, but instead was like the AI generalized in a really problematic way based on what like inner objective it had, or like how like its heuristics or like motivational complexes.
Okay.
But at the same time, it's not really like super well described as either, because if you did have perfect feedback, it would have solved the problem. Or if you had better like mastery over the internals and what the internal structure was, that could have also solved the problem. And like it's just like didn't decompose that well.
Okay. So for you
sense?
that counts as scheming, but like
No,
that doesn't count as scheming.
that specific case doesn't count as scheming, because the reason why the AI took bad actions eventually was not that it was like in like playing nice. It was just that it was like doing the same thing always. Like in the simplest case, it was like, I want to achieve this proxy, which was historically correlated with what got reinforced.
Okay.
And then like in some new case, the best way, like the way that naturally generalizes, would be to like seize control.
Okay. So for you, scheming is when you're like when you suddenly start trying to do something different than what you were trying to do previously?
No, scheming is like when I'm trying, the reason why I'm performing well is because I have long run aims that I want to achieve.
Okay.
So I think also called like deceptive alignment or whatever. Like the reason why the AI looks good isn't because like it's just like doing the thing on its own merits. It's because it's like, if I look good now, then that will acquire power and influence for me in the future, or maybe for a different AI in the future. And
Okay.
that's like pretty different. So like in the case I was describing earlier, the reason why the AI performs well is it's like, for example, I'd like to make the human press the thumbs up button. For example, though, like probably it's some more complicated mash of heuristics that is historically correlated with like performing well.
Right. So somehow inner and outer alignment is sort of talking about the distinction of like, is the thing you were worried about is captured by the reward function, whereas scheming is like, is the reason you did that thing like because you wanted to achieve some crazy outcome later, or is it like just the obvious?
Yeah. I feel like another general takeaway is like, I think people in the safety community often have things that are better thought of as threat models, which they then think about as like things you're trying to achieve for safety. So I think like outer alignment versus inner alignment is an example where I think it is clarifying to think about misalignment due to bad rewards
Yeah.
and misalignment which is not due to bad rewards. And I think those are useful frames or like can be useful decompositions. But I think being like our goal is to achieve outer alignment is like a pretty confusing way to think about the problem, which is of course in some sense not a very novel take. I think people have expressed somewhat similar things in various contexts.
Sure.
Same for alignment versus misalignment also.
Okay.
Yeah.
So if somebody's listening to this and they're interested in like, trying to work on the control agenda, trying to push it forward, what would you encourage them to do?
I mean, it's plausible that suppose they're a researcher and they want to research control stuff. It's plausible they should do research projects on this. I think there's a lot of obvious follow-up work to do on our paper. A couple of people are working on stuff like that, I mean, including us.
Okay.
They are welcome to email me for advice on doing control projects. I think there's like reasonable ML papers you can write about control.
Right. What are some examples?
So for example, the thing that I'm doing literally right now is a follow-up, or sorry, literally right now I'm recording a podcast, is similar to the control setting, is similar to our previous paper, except instead of the task being writing code and the catastrophe being the code being backdoored, the model is an agent in a bash shell solving various random DevOps problems for you, and the catastrophe is it running malware that it downloads from the internet. This is just a different setting. It's going to demonstrate different failure modes, and different protocols are going to turn out to be the best. And then I think from doing this project, we're going to learn some things that we didn't previously know about which protocols, the extent to which protocols work in a variety of situations, which things generalize from our previous paper and which things don't.
Okay.
To choose an example of a very different type of thing, you could try to do a control paper where there isn't a catastrophe that it's unacceptable to happen even once. You could do what we would call a low stakes control experiment, where the safety is just the proportion of actions which were taken that were bad. So you could just take our setting, except imagine that after submitting a backdoored code, you just get like one safety demerit point.
Yeah.
But the setting doesn't finish, like the scenario doesn't finish, and that's just another setting where the protocols are going to be somewhat different.
Sure.
And closely related to that, I think the central case in which you see like low stakes type stuff is like you wanted to do a bunch of work with your AI and you were worried that it would be systematically sabotaging that work. And so we're pretty interested in work that looks like you have AIs do like, for example, the nicest case would be like you have AIs do like a bunch of small research tasks, and then the question is like, can a red team create an AI that like systematically sabotages those research tasks such that you like yield like incorrect conclusions a high fraction of the time? And it would be like fine if you got incorrect conclusions like 0.1% of the time, but it would be like really sad if you got incorrect conclusions like 10% of the time. And like the question is like how much can you cut down that percentage of the time that the like answers are like intentionally wrong, or like this sort of thing.
Other work you could do is if you work at an AI lab and are influential in them writing their responsible scaling policies or analogous documents, you could consider trying to ensure safety via a control type approach. If you are interested in thinking about regulations that would ensure safety, you might consider using these types of ideas in your regulations. If you do technical research at safety labs, you might consider thinking about that research in this frame. Like a lot of work people do on that they label as scalable oversight work or a couple of other types of things can be framed in terms of control. And I think the work would be often somewhat better if they explicitly adopted this frame and did control evaluations.
Also, yeah, feel free to contact us if you want to talk about some of this stuff. Or like particularly about if you're like a technical safety researcher who is like about to do your next project, definitely feel free to contact us. And I think another thing that's like closely related is that I think like in labs RSPs, or the equivalent of RSPs, they should have policies for what they do if they catch the AI. Like as in one of the like key things is that we've talked about is like, okay, our goal will be to ensure that we catch the AI before it causes problems, but we should also have a proposal for what's going to happen when we catch the AI. And I think this is somewhat under discussed of like, well, we're going to want to be able to make sure that we have some probability of catching the AI. And then also we need to have a plan for what happens, and we need to like be ready to shut things down and be ready to respond and have all of that set up and ahead of time.
Right.
I want to clarify, read the previous point that we do, in fact, talk to people from AI labs rather
Indeed.
than merely appear on Axerp hoping that they reach out to us.
Fair enough. So speaking of things you might want to clarify, before we close out the interview, I'm wondering, is there anything that you guys wish that I'd asked?
I mean, I think there are many topics to talk about, but I don't think there's any specific one that seems that important.
Fair enough. Well, if people listen to this podcast, they're like interested in following you two or Redwood Research in general, or maybe they want to reach out, how should they do that?
They can find our emails. They can follow me on Twitter. They can follow Ryan on Less Wrong.
We're probably going to spin up a blog at some point, but we haven't gotten around to it yet. And so you can follow our blog, which is just going to be our Less Wrong posts, but on a different website. So if you prefer a different website for some reason.
Okay. And it's possible that, given production timelines, it's possible that the blog will even be out by the time this episode airs. Who knows?
Indeed.
And your emails, I'll include that in the description of this episode.
Great.
Yep.
All right. Well, Buck and Ryan, thank you very much for coming on Axerp.
Sure.
Thanks.
This episode is edited by Jack Garrett, and Amber Dornace helped with transcription. The opening and closing themes are also by Jack Garrett. This episode was filmed at a location provided by Lightcone Infrastructure. Financial support for the episode was provided by the Long-Term Future Fund and Lightspeed Grants, along with patrons such as Alexei Malafeyev and Tor Barstad. To read a transcript of the episode, or to learn how to support the podcast yourself, you can visit axrp.net. Finally, if you have any feedback about the podcast, you can email me at feedback@axrp.net.